Are we excited, guys?
And
Yes.
I don't know. I'm so excited.
I'm super excited, man.
Like,
yeah.
Nice background, Lucky.
Thank you.
to be honest, we really didn't think we are gonna get so many people.
We clocked 800, by the way.
Yeah.
Registration.
Well, that's the number.
Yeah.
Yeah, in 1 week.
Yeah.
Wow, that's pretty amazing.
Amazing.
We were like, maybe we shouldn't do this because there's just 1 week, and
well,
yeah.
All right. I guess we're 1 minute early.
Yeah. Francesca says maybe you should do this more often.
Actually,
we will.
You're right.
Yeah.
I mean, we're really lucky to have such a community who's super enthusiastic about sharing. And it was actually very hard to, when we did an open call, it was very hard to, filter and come down to the people who are going to be teaching today. So there were so many said that we can't do it now, but later on we would love to do it. And so this looks like something we can do 3 to 4 times a year, I guess.
Yep.
Let's see how it goes.
Yeah, let's see how it goes, though. Yeah. So actually, I just want to thank everyone for showing up. I'm Arek, co-founder of Futurely with Vamsi.
Hey, guys.
So this is the first time we're doing such a thing, right? This is considered to be a pilot of sorts. We don't have a model that we're following. We basically wanted to do something that wasn't just about us, but also involve the community. And like I said before, we were super lucky to basically just announce this, and so many enthusiastic people wanted to join. And today, basically, we will introduce them separately one by one as well. But we have Nicolas Vanni, Arthur Azoulai, Stefana Zapuc, Teddy Fadous, and Arav. Kumar, who's going to join us to be sharing their knowledge. So thank you guys once again for doing this. For the participants who are going to be watching, I just want to say that it's all going to be 1 hour tutorials and bits of knowledge. There might be things that you don't know or you need more fundamental knowledge about in the specific software to follow that specific tutorial. So I would suggest not following along, but taking the information and applying it later, because in 1 hour you might fall back and not catch a lot of information. And so, but if you're really confident, do follow along, right? You have all the files and everything to do so. And we do have a surprise at the end of the 4 sessions that we're gonna say about
it.
recording being available. We even have babies attending though. So
who are you calling a baby?
Exactly. So yeah, thank you guys once again, and without further ado, because we don't have a lot of time, I'll let Vamsi introduce the first tutor, and we'll get to it. And by the way, I would suggest turning off your cameras so we can have a very fast connection. And then at the end of everything, we'll do a big selfie with you guys, I promise. And by the way, we also sent you the link for the Sanzar party later, and it's going to be pretty awesome. So you don't want to miss that. It's just that we realized
we don't
35 people limitation per world. So basically, if you join after 35, you're going to be with another 35 people, but still the experience is the same with the music, the lighting, and everything. So if you do so, please let us know what you think. All
yeah,
right.
guys.
And we'll be in the chat to answer any other questions. All right, Vamsi.
Awesome. So first up, we have Nicolas Divani presenting bending active shells. So I couldn't put it in full screen for some reason. Anyways, yeah. So this is his workshop, guys. You've seen the poster, and you can follow Divani on Instagram at Alpalonco. This is the handle, and we hope to see a lot of amazing work produced through the sessions that happen today as well, because most of the sessions are curated in such a way that you can produce an outcome in each session. And all the workshop files, as Eric mentioned, are also being shared with you. So please try to follow along and also produce some amazing results like the through the workflow and share with us. You can tag Futurely Space and you can tag Alpha Lonco, and we're going to repost all the stuff you make. So getting to the introduction, Nicolas is an architect and computational designer from Chile. He completed his master's degree in parametric design in Barcelona and now runs his own studio in Santiago de Chile called Nuema Studio. I hope I'm pronouncing it correct, Nicolas. Yeah. He currently
Yeah,
works
it's
on
okay. It's okay, Vamsi.
uh-huh. He currently works on developing parametric approaches to projects, supporting designers in South America and Europe, mostly creating lightweight and bending active efficient structures. Nicholas has always been passionate about computational design and digital fabrication, and most of the years have passed since his journey started in computational design. And since then, he has always been exploring the infinite possibilities that lay in the 3D world. Over to you, Nicholas. Get started.
Okay, are we guys ready?
Yo, man.
Um, you need to allow me to share my screen, Vamsi.
Just a second.
Will some of these videos be recorded so that we could kind of go back if we can't keep up?
We will announce the what. Yes, it will be recorded. It is being recorded right now. We will announce how long it will be available for you guys at the end of the sessions.
Okay, thank you.
Yeah.
Can you guys see my screen?
Yes, Nicholas.
And can you hear me properly?
Yes.
Okay, I'm gonna be sharing with you guys an exercise I did on my master's degree in parametric design, which is a bending active shell following a Kagome pattern. It was a project developed by Coda, my teacher's office, and basically we're going to create this kind of grid starting from a triangle mesh, and we are going to use the root goal in Kangaroo, and we are going to push these boundaries to create this bending shell, as if we using planks. So in this kind of structures, we are going to be using the bending in our favor to create this kind of covers. So in Kangaroo, we are going to simulate these curves. They are going to be rods that wants to be flat, and we are going to push these boundaries and to create this kind of shells. It's going to be fun. It's an exercise that I liked pretty much, and at the end I will show you guys how we can iterate over this and create like a lot of different structures. This is the project. So the cool thing is like they build this thing flat in the ground, and they push the boundaries, and using the bending properties of the wood of the plank, you create this kind of structures. So with no more to say, let's get hands-on. I hope you guys have the initial file ready, where we have this mesh. Basically, what we are doing here is creating an hexagon and the inner triangle. And we are going to be creating these circles to further remove these faces from the mesh. And this is going to be the places where we are going to create the supports. Okay. So we have this. Basically, it's an exploded mesh where we retrieve the indexes of those faces and we just remove them. So we have this result. Okay. Starting from this point, we need to create this kagome pattern. So to do that, excuse me a second, we need to retrieve the midpoints of these lines, of these triangles. So we are going to get the face polylines from Weaverbird. Where is Weaverbird? Okay. We're going to retrieve the face polylines, explode them, and get all the midpoints. We are going to use point on curve, which is one of my favorites nodes in Grasshopper. Very useful for me. Point on curve. Where is it? Point on curve. So you connect the segments here. And this number is like the line. 1 is the whole line. So 0.5 is going to be the midpoint of the line. Okay. To create this kind of interlocking pattern, we need to move these midpoints. So we are going to add a move component. Unit set. And we are going to move them like 0.02 or something like that. This will do. Can you guys hear me properly?
Yes.
No.
Yes.
Okay. So we are going to create new lines for this guy using the segments. What's going on here? From curve to point.
Nicolas, do you have bifocals you can use?
Oh, sorry. I don't have them, but I will add them in just a second. Sorry, guys, just a second. Bifocals. Okay. Okay, so we are going to create the new lines. Okay. As you can see, we have this interlocking pattern from here. We need to create, first we need to do a shift list to create the hexagonal weaving kind of pattern. So we are going to do a shift list. We are going to use these guys from here. These guys from here. And using the midpoints of the face boundaries, we have this new interlocking pattern, which is a very commonly used pattern in Japanese basket weaving. It's called kagome. Shigeru Ban has worked a lot with these patterns. It's pretty interesting. So let's follow up. The new curves, we are going to join them because, sorry guys, we're going to further use these curves in kangaroo to simulate these bending rods. So basically what we are going to say is that these curves wants to be flat. They want to rest at 0 angle, and using the connections between them, they are going to be bending and create this shell purely from the bending properties of the wood. So we have created the new lines. Now we are going to create the connections in between them. It's going to be a little bolt in between these new nodes to hold the whole structure. So we are going to create a new line from the midpoints, which are these ones. Sorry. And the displaced ones. Sorry. From here to here. No, sorry guys. This is going to be the moved ones. We need the midpoints and the moved ones. So okay. We need these ones. All again. We need these ones. And we need these ones. Okay, that's it. So we have, it's a good practice to add these nodes and to name their geometry. So we are going to call these connections. you can just press this little icon here and rods. We're going to call this rods. And turn everything off. So we have a clear starting point. So we have created the Kagome pattern and the interlocking connections, which are these little ones. Okay. Now what we need to do is to isolate the support points. We need to identify all these nodes that are going to be pushed to the boundaries. So to do that, we are going to create we're going to use endpoints. Boom. And if we add another geometry node and use the start points and the endpoints, sorry. Uh, can you guys hear me properly? It's the sound okay? Let me review the chat. Okay. It's okay. All right. We need to flatten this list. So reaching the start points and the end points, we add them to a new geometry node and we are going to get the boundary of the whole structure, okay? Now, if you can see here, we want to create some kind of arcs and push these little points to these arcs. Okay, so we are going to create the circles. We are going to create a vector. We are going to push that arcs through the vector inwards. So the whole shell starts to bend. Okay, so to do that, we are going to grab the circles. Geometry. Okay, we're going to call these circles and grab these guys from here. And we're going to use a node called point in curve, also a very common node in Grasshopper. Okay. We want to sort of test the all the points per circle. So we're going to be adding a point on curve, point in curve, sorry. And we are going to be grafting this input where we are going to be adding the circles because we want to test for each circle individually to see which points are correspondingly to that circle. Okay. So we can also add a scale node to have further control over these new circles. We are going to get the centroids of those circles. So we're going to use an area node. Boom. scale it from here, and let's say 2.0 to scale these guys. Boom. This is only needed because you want to have further more control over which points are you going to be grabbing. It's not 100% mandatory, but for me it's a good practice. So we need to add these circles in here, and we need to grab these guys in here. Boom. And there's also a very common node called cool pattern. If you see here these outputs, sorry. Let me see if I can admit, okay. These outputs are booleans. So this is kind of a yes or no. So we are going to use a cool pattern to isolate the points that are corresponding to the circle we are adding. Okay. So we are going to test these roads larger than we are going to use this result. Oh, sorry. This result and this one here, and we're going to test the points. And now we can scale a little bit our circle. So we have our new isolated points, which are the points we're going to push inwards to create the bending structure. Okay. Let me just organize this a little bit. Let me see a little bit the chat. Okay. Now we have isolated the points. Let me minimize this. Okay, now we have isolated the points. And we want to kind of sort these points. We're going to use sort along curve. And we are going to use these guys. And also we are going to use the boundary curve. Here we need the boundary curve. So to get that, here we have the connections. Let me just group this, add a color. To recognize it easily. We are going to grab the starting mesh that is here. Boom. Just to note, guys, here in the initial mesh, we have created this mesh, and then we subdivide that mesh. And this comes from exploding the faces and removing them. So just for you guys to know, here, if you can see, we have 480 vertices and 432 faces. If we use this welding and this node is called join meshes and weld, you can see the mesh has a lot of duplicated points. You can see 480 vertices, and after using this node, it's only 244. So we use this guy for cleaning the mesh a little bit. Okay. So from now on, we need the boundaries. So from this point, we are going to use Weaverbird's naked boundary. This guy here, boom. And we are also going to use naked vertices, which is also a node from Kangaroo. Naked vertices. So we're going to add this guy here. And if you can see, and sorry, the naked points output gives you the points from the boundary. Further to that, we are going to explode these lines. Explode these lines. Use a shift list. What shift list does is for example, if you have this list in here, the shift, it's going to be shifting this little index number. For example, let's say 5, sorry. So we added like 5 more spaces, and now if you can see this number 5.7777 now is the first one because the list has shifted 5 places in the whole list. Okay, so that's what shift list does. Okay, so we are also going to need a curve closest point. This guy in here. Test again for every circle. So we are going to be grafting this input. And we are going to be adding the circles in here. Boom. And using the naked points. So all these points, this little node in here just shows us it asks you for sorry, alloy admit for points and for curves, and it will show you the closest points in relation to the curve you are inputting here. So we want to test for every curve, and that's why we graphed. Let's clarify this a little bit. Graphed. So for you guys to understand what graph is doing, now you graphed the list is isolating every point in their own list, and without flattening it, you have one list with all the values. Now we have grafted it, we have one isolated list per item. That's what graphed is doing. Let's delete this. Let me check out the chat. Okay. Boom. Now we need to create these little arcs that I mentioned at the beginning. So to do that, let's say, let's remove. This is also a good practice. Always test for duplicated points. And here, in this case, we have a repeated endpoint. So if you can see here, it's 55 values. After this node, it's removing 1 point, which is duplicated. And we're going to create a polyline. We're going to create a polyline to get the boundaries. And we are going to use a smaller than and a cool pattern. And we are going to be connecting the naked points, which are these ones, to the call pattern. We are going to test the distances. Let's say 0.55. And add this guy in here. And now if you can see, we are measuring, let me organize this a little bit. We are measuring the distance of all these points to these curves. Okay. And with this little node smaller than, we are measuring here distances. So using those distances, we actually get the points in the boundary that we want to push through our arcs. Okay. Any case, guys, if you feel lost or something, I'll be with you in Discord. Anytime you can ask me anything. So I will just move forward. But
Nicolas,
basically here we are isolating the points we are going to push. Sorry.
Nicolas, I'm just going to ask you to check out the chat every once in a while. Like, basically, there's
Okay.
two questions. One of them is, can't we use call pattern directly? Or do we need larger than? And the other one is, why do we use shift list? But I guess you explained why do we use shift list.
Yeah. Because for the shift list, furthermore, we're going to be creating arcs in these isolated points. And if we do not shift the lists, the one of the arcs it's going to be redundant. I will explain this in a little bit. And can we scope pattern directly? Here every points are going to push to here every points are going to push towards mid or basically we are going to be creating a vector, a direction inwards. Inwards this center, and these points are going to be pushed through an arc. Let me check. You want to recap with that, or is there something to be better explained? From Catherine, can we use code pattern directly? Do we need larger than? We are using this smaller than. If you mean this guy, just to isolate the points. Grasshopper is like a world of possibilities. This is how I managed to resolve this exercise. Of course, if you feel anything can be do better, you can do it. I'm just going to show you how I did it. in this case. But of course, if you feel that something can be improved, you can, of course, improve it. So without losing more time, I'm going to move forward. And okay. Let me remove this guy. Exactly, exactly. I'm gonna be with you in Discord uh, forever. So any question, we can reach up there. Okay. Here, if you see this little input, it's not closed. We can just go in here and set it to true, and we have the closed polyline and the isolated points. So in this case, we're going to use a sort along curve. Boom. We're going to use the pattern in here and this curve in here. We're going to use another cool pattern. Let me see chat. Uh, I'm not really good at kangaroo. Well, it's just practice. It's scary at the beginning, but basically it's a lifesaver, kangaroo. It can solve, for me, it can solve almost anything. Dan Piker, the creator of Kangaroo, has done an amazing job with this solver. And basically, most all my problems are solved through Kangaroo. So just practice and now you will learn a little bit about bending rods in Kangaroo. Okay, with no more time to lose. Here, what we want to do is to create these little arcs. So if you create an interpolate curve in here, you may notice this weird shape. We don't want this, we want an arc. So we are going to use another cool pattern. And we are going to set the booleans to true and false. Boom. This guy goes in here. So we have removed some of the points with a true false pattern, and now the arc is created properly. So from now we are going to add a little box. Let me see chat. I wish I get problems like you in live, Nicolas. Okay. Well, so we have these little curves that we are going to be using to push inwards the whole grid. Sorry. So we are going to name this boundary curves. And in this little list here, we are going to sort these guys using the boundary. This is my first class ever, guys. So if I am a little bit sketchy, sorry. It's my first time doing this. I'm trying to do my best. But just to say again, I will be at Discord to solve any of the doubts you may ever have. Okay. Now we are going to use a dispatch. Dispatch. And what this node does is you just give a list, you input a pattern, mostly like cool pattern. You input a list, you give a pattern or a mask, and it will split you these lists. Okay, so we are going to use these sorted points. Boom. And if you see here, let me just grab a panel. We have several lists with 12 values. 12 because 0, it starts from 0. And after using the dispatch node, we kind of eliminate the duplicate points we might have. Again, guys, this is how I solve this exercise. Maybe there are better ways to do most of the things. So again, if you feel something can be done better, you're just good to. What does sort along curve command do? It's just exactly Jaya Navina. Basically, you're just ordering. Should we worry about list branches as in simplify? Can you zoom out because I don't know where you're gonna curve in sort. Can you zoom out grasshopper because I don't know where you're gonna curve in sort along curve. Okay. Let's go again. We are here in sort along curve, you are going to be testing the boundaries with the, the boundary curve with the points for supports. Okay. And after that, you will get these little dots. And as I was explaining, we're using this dispatch node to reduce list and to eliminate redundant data. Okay. Okay. Now we are going to be creating this sort of vector to displace these little arches. So to do that, we are going to grab the midpoint, this guy in here. I'm going to bring it here. And we are going to be creating a line, between this central point and where is my area node? Here. We're going to be creating a line using this center and these points. And this one is going to be the vector where we are going to be displacing these arches from the boundary. So let's grab this in here. Let's say vector, displacement vector. sorry, displacement vector. And let's grab an amplitude. And let's unitize the new vectors. So we have these lines, unique vector. This little guy is just retrieves the 1 unit value of a vector. For me, it's good practice. So let's unitize it. And let's put this to an amplitude node and add a little slider. Boom. Okay. We have these little boundary curves that we want to move. So we are going to use a move node. Add these guys in here. Grab this input. And we're going to be having this. So this is the motion that we are going to be using to push the boundaries inwards. Let's leave this at 2.0. Let me check the chat a little bit. Okay. So we are going to be grabbing the anchor points in here, these ones. Project them to the plane because they do not share the same heights, if you see here. So we're going to be projecting these guys to the XY plane. Boom. Project points. We are going to use this distance, this geometry, and this plane. And we are going to be grafting this input. Now we have all the points sharing the same height. Okay, now let's clean everything a little bit before reaching into Kangaroo. So we are going to create, this one is going to be anchors. This is going to be targets. It's going to be rods. And this one is going to be connection. Boom. So basically what we want is these points are our anchor points that belongs to the whole mesh. We want these points to be anchored to these targets. Okay. If you notice, we move these guys. So anchor and targets is just the points and the place where you want your points to move. Okay. We are going to isolate the rods too. Where are they? Give me a second. Okay, this guy is in here. And also we are going to isolate, sorry, chat. Okay. We're going to be grabbing the connections too. So they are, if I do not get about it, here, these little connections in between the lines. We're going to add them in here. So we have a clear starting point to mount on the Kangaroo solver. Let me just turn this off. Okay. So we have our moving boundary, and we have all the pieces of our structure. So we're going to be adding the Kangaroo solver. Kangaroo. Sorry. Solver. This guy in here. And what you need to input in Kangaroo are called goals. So if you go here to the Kangaroo, to the Kangaroo tab, you will see a lot of different goals. They do pretty a lot of stuff, but in this case, in this case, we're going to be using the angle goal and the length, which are pretty common goals in Kangaroo. We're also going to grab an anchor and unary force. No, not unary force. That's load. It was called unary force in the other versions, in older versions of Kangaroo. Okay, so also a show. I will explain all of this in a second. And an entwine node. Boom. So basically, these are kinda rules you add to the geometry, and they go through the solver, and it outputs you the data. So in this case, the angle goal, what it's saying is that all the rods wants to be flat, but they have some sort of bending resistance. So it will push other rods because they are connected together. So what you actually do with this guy is input a line and input the next one. I will show you how to do this in a second. Say a rest angle and a strength. So the rods will act as they have bending properties. Length, it's a pretty common node in Kangaroo. Basically, you use it to make the lines of your structures to try to reach certain length. So I can make the whole structure elastic just inputting length 0. So all the lines will compress, or in contrary, you can add more length and make them larger. Anchors is where the whole structure is going to be supported. So you can input your points and targets. This means I have my anchor points and I want them to be pushed to this position. And this load, we are going to be using it to help a little bit the simulation to converge. These show nodes, it will grab your geometry, pass it through Kangaroo, and brings you will bring you your new geometry. So that's what you need to show. Okay, so let's mount all this. For the rods, we're going to explode them. Sorry. Oh, boom. And we're going to use a command called shortest list. In here, we're going to add a shift list. And set the wrap to invert. So it's false, okay? What we are going to do here is to put in the segments from here. The segments in here. Let me check the chat. Yeah, Vamsi. Let me just give me a couple more minutes. I'm just about to finish.
Sure, Nicholas, all good. Yeah,
Yeah.
just letting you know.
Yeah, we can suggest that we don't stop for chat questions. We will gather all the questions in the chat and answer them in Discord later. So keep asking questions in the chat, but we'll basically gather them all together for Discord to be answered later.
Yeah, just to say again, we are going to be on Discord whenever you want. So feel free to ask anything.
Cool.
So let's move on. So basically what we want to do here is to input one line and the next one to simulate like they want to rest and at certain angle and they have tension. So here we are going to use this guy's shortest list. You can Google this later. I have no time to explain what it does, but basically, it will give you the shortest list. Yeah, sorry, the redundance. But imagine if you have like this pair of lists. So, for example, you have 10 points and in other list you have 11 points. The shortest list will give you the shortest possibilities of those lists. If you use instead longest list, sorry. If you use this guy instead, the remaining point will try to connect to the other points. Sure, someone can explain this better, but for the sake of time, we can solve this later. So let's input these guys in here, A and boom. And let's say 0.001, because of course they are never at a fully 0-degree angle. We are also going to add the segments to the boom, to the line. We're going to grab our anchors, our targets, and what we want to show is our connection and our rods. Sorry. Boom. This one here, this one here, this one here, Let's add a little bit more inputs. This one here, and this guy in here. And input this to goal objects. If you see here, we can use an explode tree. It's a little trick I learned not so long ago. If you write bang, it will give you the explode tree node. So if you see here this input, you have 5 lists. So let's add 5 in here. And this is going to be correspondent to what you input in the entire node. Okay. Here, let's add a button and a toggle. And put this guy in here, reset. Not working pretty well. We're going to be solving this in a second. We're going to be using this little unit reload to help the simulation to converge. So I'm going to add multiplication. Another button. 0.01. Boom, boom. Oh, sorry. This guy in here. Here we need to input a vector. Sorry for that, guys. And we are going to be using the vertices of the rods in here. Boom. Let me see chat. Well, I will answer the chat after finishing, guys. Let us solve this thing. Let's check what's going on, and let's check what's going on. So we have the connection, the rods. Let me clean this a little bit. And also let me check what do we have here. Just 1 second, guys. We have our connections in here. Let's add another one of these ones. Connection. That's it. I was missing to add the length goal to the connections, guys. So let's turn this off. And as I told you before, we are using this little helper just to help the structure to help it to converge. So Let's say 1. Okay, that's it. But it's not going um, to the direction we want. So we can use a negative go and help it to go forward. And now we have our bending rod structure simulation. And basically, wow, there is it. Basically, you can start playing. If you come back here to the initial one, you can decide where to remove the faces of your mesh and where to create the boundaries. And you can test and generate like several meshes. If you see guys here, I already pre-made a lot of meshes for tests. What you want to do in this case is just to isolate the boundaries, just as we did with this mesh, with the first one. And for that, you are going to be using the circles we created at the beginning. It's just the same process, and we are running out of time. If you see, guys, in the files I've sent you, you will see a definition to actually transform these curves to geometry, and to get actually to make this curve structure to be actual geometry. So I run out of time, guys. I did my best to teach you this. And if you have any questions, I will be happy to answer you anything in the Discord chat.
Thank you, Nicolas. This was really, really great. Please don't forget to save the file so we can upload it to the Dropbox as the final file, if we haven't.
Yeah, I already sent the final file. It's better, I think, than
Yeah.
this one. It's more clean, so you can download it from there. And again, if you have any question about this, I will be happy to help you guys.
Awesome. Thank you so much for sharing, Nicolas.
Awesome,
This was really
Nicolas.
great. I think you do deserve to have some more confidence in yourself because you're doing really great. I really enjoyed the class myself as well.
Yeah, I was a little bit scary because it was my first time doing this.
You're a natural, to be honest.
It was a little bit sketchy sometimes, but nah, just happy to share this little bit of knowledge.
All right.
It's a pretty fun definition, and actually, if you want to build this kind of structures, it's pretty easy. It's just weaving straight planks. So again, if any of you guys think or want to further develop this, I will be happy to reach you. And that's it, guys.
And awesome.
Thank you for the opportunity, Arek, Bamsi.
Thank
you,
you.
man.
Thank you for stopping by. It's your time. It's your knowledge.
Yes, it was a great short exercise. I think it
Yeah.
was fantastic.
All right.
Glad you like it, guys.
Yeah. See you soon on Discord, I guess.
On Sansa,
Yeah.
On Sansar, I guess, in a bit, in like.
Yeah, for sure.
Yes.
But awesome. Cool.
Yeah.
All right. On to the next Twitter. Thanks, Nicolas, one more time.
Thanks again, Nicolas. Bye-bye.
Thank you, guys.
Yeah. Next up, we have Arthur, guys. Arthur can be reached out on Instagram through Arthur Azoulai and through his company at Slice Lab. I hope you can see my screen. And Arthur is a co-founder of Slice Lab, founded in 2012, a design studio and an experimental think tank for exploring innovative design techniques and advanced fabrication methods. Arthur also has an international and varied design background, having worked with Jacob McFarlane, Francis Bitonti, and Rockwell Group. Welcome, Arthur. The stage is yours. Arthur, are you here? Oh, yeah. And guys, this webinar by Arthur is going to run using Maya, so please turn on your Mayas. It might take some time to load, I think. And of course, Rhino and Grasshopper as well. Arthur, you're muted.
We can't hear you, Arthur.
You're on mute. He's giving us some signs.
that was really
good.
cool.
Thank you. I was like, you got to unmute me.
Right, done.
Awesome. Thank you guys for the intro. Great. Well, I'll do share screen now, and I'll turn off the video just to make sure the bandwidth is better. Start video. And I'll turn the chat on just so I have that nearby. All right, can you guys see the screen? I'll take that as a yes.
Yes.
Okay, cool. So basically, this tutorial is going to go through technique I learned during my master's back in the days. It's using Maya and the hair system solver that is within the software. I'll show you some examples of the work that I've done using this. So this is a line of jewelry that we developed a while back using this system, basically. And then we'll go through some quick exercises to get you familiar with how it works, how the ring was made. I showed you this ring. And then these are some of the jewelry that was made with it. The same technique, basically. And then looking at like three-dimensionality of it, how you can start creating some kind of structures with it. And lastly, this is a project that was done at school, so using the same system with different techniques. So awesome. Let's start. It's going to be mostly in Maya. We'll just run you through how I go about usually creating the curves very quickly. And then you have in the Dropbox, you have all the files from the initial files to the final files with the solver already in there. So you can start that at any time. So basically this set of curves was just done really quickly. With the Grasshopper, you can do it by hand. It's really however you want it. And these are the results that you get. So let's start already the process. So if I want to take this grid, or we'll take this one, it's a little bit more fun. So from Rhino, you want to export your curves as IGS files. So we'll do one curve. All right. So now from that, turn Maya on, and then I'll show you how to get the hair system working. It's pretty basic, and then we'll go through how to get it working in 3D and seeing how you can adjust some settings to make it look a little bit different. And then at the end, we'll see how to 3D add some geometry to it. So in Maya, I want to import. Oh, make sure in Maya, actually, we'll do this first. In your Windows, okay, you're a little slow to start today. Hello, my friend. There we go. Okay. The plugin manager, if you go down and find this IGS plugin, make sure it's loaded and on auto load. That's what's gonna let you import IGS files. So you can get the curves into Maya and export them later if you want to bring them to Rhino or any other software. So close. Now I'm going to do import. Grab the curves, import. Okay, so now I get like all these curves in the outliner. And if you have questions about like more of the interface, I want to focus first on this exercise, and we can look at those questions later. So what I want to do is Control G, group, just so I have that in a group there. And then the first thing I'm going to do is let's see, can I hide this? No. There we go. Curves here, I want to do rebuild. And basically the number of spans here is going to start defining how the curves clump together, because the hair system is using the points, basically the CVs of the curve. IGS from Rhino to Maya. Sorry, I'm looking at the question. Maybe from Zoom. Yes, IGS from Rhino to Maya. Where is it? Here. Export selected. We'll just save over. And when you hit the save, sure, you get an option here. I usually just leave it, put it on a Maya, and millimeters, units, that's however you want it. I would just keep it to that, to whatever the default is. Okay. So number of spans, you don't want to do too much because then it's also going to take longer to compute. So usually I like to do between 12 and 30. So let's start with 12 and then we'll see how that looks. So what I like to do after this is, because this is my initial set of curves that I've brought in, and we're going to change them to a hair system. So before doing that, I like to duplicate it and hide the original by just pressing H, just so in case I want to change it, I can always go back to those initial curves instead of re-importing every time. And now we're going to look at how to make these curves dynamic. So in your Maya, in your FX tabs, we'll go to that. Let me hide this again. All right. Go to that, and before anything, I'll make sure, well, we'll see that later. So select the group, and in N hair here, I'm gonna click on make selected curves dynamic. And so you see what that does is that my group of curves here is now being transformed into what's called follicles in Maya, creating a hair system node, a nucleus node, which is the solver, and then the output curves, which are going to be the curves that get animated. So And you see now I can press play. You see something, those curves are being animated, right? And those are the output curves. So what I'll do is the group 2, what the follicles are, I'll just press H, hide those, so I just have the final output showing up. So if I press stop and go back, what we're basically seeing is gravity working on these curves, right? They're like going down and kind of falling. So in order to create this clumping kind of system of the strands, we'll go to the hair system here, select this one, and in your attribute editor, how can I move this? Oh, there we go. Attribute editor, we'll go to hair system shape 1. And basically this is where all of the like settings are going to be set up. For this to work, I've learned this back when it was like Maya 2012, and I found that even with this new one, they added this nucleus solver. I still prefer the look and feel of the older kind of system. So I've found ways to just bypass this nucleus solver. You can just turn it off, and then you'll see if I press play. Now it's like a little bit different. The gravity is not playing as much of a role on it. So that's good. And then we'll look at basically a bit of all those settings. So turn on collisions, turn it on, dynamic properties, and turbulence. Those are going to be the 3 main tabs we'll adjust for this. And the first thing I'm going to go to is within the dynamic properties, there's a thing called forces. And because this is flat and I don't want gravity to play on it, I'm just going to turn gravity to 0 and the mass to 0. Everything else I can just leave it the same for now. So press play. Now nothing is happening, right? Okay, so go back to the first frame. And then what we'll see here is that it's on in collisions. If you go back up, it's on collide. And what we want to do is basically the curves to self-collide with each other to start clumping together and creating these forms, right? So turn collide off, turn self-collide on, and then if you press play, nothing happens yet, right? So the biggest thing we're going to have to change here is the static cling, the collide neighbors, and the repulsion. And that's where you're going to start having fun by like pushing and pulling those values. So static cling, usually I'll start around 50 and see what it does. And that's kind of my favorite part about Maya, is that it's a lot of playing around to get to the final result you like. There's no one good answer. It's just, so obviously that's not yet working. Repulsion, I like usually to do 1. Let's turn this to 5,000, see what it does. Okay, already you see something is happening, right? But that's like doing too much. And one thing I like to do also is here, just for the animation, for your timeline, just put it at 500. So that animation kind of runs a little bit longer, right? And see what happens through time. So this goes very quickly to this position and doesn't want to move. So then I was at 50, now 5,000, let's do 200, see what happens. Still nothing, my friend. Okay. 1,000. All right, some movement is happening. But now what I want to do is basically here, the collide neighbors, I want to turn those up to 20, because what it's going to do is going to look for more points around basically to clump together. So if I do that, I can start seeing movement in here. You see, if I go back, up, movement where curves are like pulling towards each other slowly. Once you have that, basically what I want to do is I'll turn the stiffness scale to 0 here. See what happens. They're a little less stiff. You see, it's like starting to move a little more. And then if you go back down to turbulence, I like turning, if you turn the speed up, speed settings, let's see. Okay, now it's starting to get a little more pulling together. And then the intensity, I'm gonna turn it up a little bit as well. See what happens. All right, maybe I can turn that up too. Go back. All right, so now I think these are good. I think it'll be mostly, oh, the stiffness here, we can also bring it down to like 0.01. Yeah, there's a lot of like weird settings in here. So it's like playing around with all of those to getting the result. But in the files that are on the Dropbox, all these settings are already there. So you can kind of play around with them already. Just wanted to show you guys how the process is of getting to where I want. Okay, so now I just start basically bringing this static cling up, and you can start seeing how this kind of comes together. All right, so I'm going to bring it down because it's a little too fast. So you can start seeing how all this comes together and creates these kind of interesting shapes. Let's see what else. Oh, collided on, turn that off. No, I want this to be a little slower. So I'm gonna do here. One here. It's a little bit slower. All right. Flex, actually, that allows for the curve to be a little bit more flexible. Let's do 0.5 to see. Then turn this up a bit. There we go. And you can even also like play with those settings as the animation is going, and you can start seeing some changes throughout. So that's kind of the basics of the hair system. Let's see if I do bring this up a bit. There we go. You start by pushing the length flex up. You start, for some reason, don't go over 1 with this. Use a black background. Yes, I can. That's another thing I wanted to show you guys well for the animations after like I posted on Instagram. Modify, no, display, nope, Windows. Settings and preferences, color settings here. Bring this up. 3D views, background here. Turn it to black. Save. All right. And then what I'll do is actually settings. Great. Awesome. For some reason, I know I was getting some issues the other day with this. The hair system output curves, I can't find a way to change the color of them. So they are blue. So my kind of weird trick about it was just selecting them all the time, just so that they're always white. All right, you can start seeing how this is working. Let me see if we change stiffness. Yeah, that's, if we change the frequency, if it does anything. Yeah, so that's kind of how the basics of the hair system work, and that's how you start using it with the different settings. One thing you'll notice is the static cling here. This changes with the scale of your curves, like the metrics, right? The scale of your curves, because we'll see in the other examples, the static lane might be like 10 and it's working fine. So it just depends on how large your curves are. All right, let's do the friction to 0, see if that does anything. All right, cool. So this is a fun little thing. So one thing I want to show you here is how, let's say this is the hair system you like, right? You like the settings that you found out. You want to apply it to other curves. So what I'll do is come back here, grab these curves, for example, file, export selected, curve initial, we'll just call it 2. Okay. Then here, I'll just bring them, import 2. So I have, you'll see, let's change the color setting for this. So in inactive here, objects, nerve curves, we'll change that to, there we go, much better. So I'll grab those curves, group them again, and then I'm gonna rebuild. Oh, and this is to get all the command. It's like you press spacebar, and you basically can get all of the menus from all the different tabs. So I like using that a lot. It's much quicker. So in curves, rebuild. For this time, I'm going to do, because there's a lot smaller spaces, I'm going to do like 30 number of spans. Just click rebuild. Good. I'm going to duplicate it again and then hide the original. I should be naming all of these for clarity, just because for timing, I'm just trying to go through this a little bit faster. But now I'm going to take these curves and here, make selected curves dynamic. And so you'll see it only creates a hair system and doesn't create the nucleus, right? Because it's basically whatever the nucleus is doing, it's using the same one throughout the whole file. But since we're not using it, now in the hair system 2, hair system shape 2, I'm just going to turn it off. And then you see all the settings are like the initial settings. But if I want to use the same settings as here, I'm going to go to hair system shape 1, this guy here, in presets. I'm going to do save hair system preset, and I'm going to do exercise 1 presets, save attribute presets. And now when I go to hair system 2, here, I'll find this preset here, just one, and I just say replace here, and you'll see it changes all of my settings already, so I don't have to go through it again. All right, so now if I press play on this, let's see what happens. Whoa, cool, right? Hide the initial curves. So now it's like where to find the start and stop, right? So let's see if I can, now that it's there, I might want to change some settings in here in the attribute. Let's bring this down to 1500. All right, let's keep bringing it down. Cool. So basically, you can play around with these settings that we changed today and see what kind of results you get. If I do 0.5 here, you start getting some cool interactions in some areas, and then sometimes it starts clumping up together. If I bring this down a bit, gives you like a slower version of it. All right, let me see if there's any other things we should look at. I mean, one thing that's interesting with the gravity, if you do want to play with it, right, is if I turn this, you start seeing it kind of like move in 3D. And I think this is more for something maybe if you guys want to play around with it. I don't think we're going to have time to cover it. How do you make it affect only one area? Like how it's affecting at the bottom here? Is that what you're asking, Patrick? That's a very good question that I honestly, this hair system is a little bit, does its own thing sometimes. So I think it's just from the start point of the curve. It's using the start point of the curve to whatchamacallit, to start the effect. And so it's a little bit tricky sometimes. That's why I like using hair system usually with less gridded stuff and more kind of either jumbled line or things that are a little bit less rigid. Just because I think the results can be a lot more interesting. Because the thing with the grid is even when you start it and once you get to the end, it's still just a grid, right? It's just a grid with some cool fillets, basically. So that's why I just wanted to show you guys what you can do, right? But I like using more random kind of curves. Cool. You guys have any questions before we move to the exercise 2? Any functions with the time bar, right? With dynamic, can we start the effect right from the center? No, so the nucleus, it doesn't matter where it is, right? Because if you select it, the nucleus is actually here, right? This nucleus is just affecting the whole file. It doesn't matter where you place it. And the hair system, this little node, right, that's showing up, it doesn't really matter where you place it either, because you'll see when we get to the 3-dimensional one, even this node moves by itself within the file for some reason. So yeah, it doesn't really matter where you place it. And then, yes, this functions with the time bar. So as soon as you set up the hair system, right, you just press play. And basically that's what I like about Maya. It's kind of like, it's a little bit less rigid in a sense that Rhino, and that's for you to decide when to start, stop. Similar to ZBrush, is like you're sculpting your whole thing, right? You're just, it's kind of really however you want it, you just stop it. And then one thing I'll run through quickly is then these curves, right? Hair system output curves is these ones. Then if you want to bring those to Rhino, Illustrator, or any other software, now that the IGS plugin is loaded, just export selection, and then you'll see there's a IGS export this guy, and you just say whatever. Curves 1. Now I'll have this. For some reason it creates 2 files. This is new. I'm still trying to figure out why this is, but then I can bring this to Rhino and just play around with it, see what can happen. It's different from the in-here algorithm. Yes, the nucleus is, it's used for all kinds of dynamic stuff in Maya. And which is why this was introduced in the hair system, I think in Maya 2017. They changed how the hair system worked. So that's why I've learned this a while back. So that's why I kind of kept using it without the nucleus, because I knew the settings a little better. I mean, we can take a look at what it does when you turn it on, right? Hair system shape, I'll go back. Use nucleus solver, you'll see that it changes everything here. All your settings, it keeps the static cling, right? Then there's a lot of new added settings that you have to play with. Then you see here now, it just doesn't really, it does some cool stuff sometimes because it's a little bit more random. Let's see if we turn this down. Static cling. Yeah, it's a little bit harder to control, I found. Where is it? And then here we'll turn the, where's the gravity? Nucleus here. We wrap this on geometry. I've done it, so I'll show you. Basically, have done it for the ring. That might answer that question. So that's a good segue to the second exercise. Okay, so I'll just save this. Close this out. Point to guide dynamic properties. So we can multi-nucleus one. Sorry, not sure this is the right question. I'm familiar with Maya. I'm not sure I understand your question. The nucleus is basically like we just saw in the grasshopper, like in the bending active shells from Nicolas. The nucleus is like kind of the kangaroo solver, right? It's your dynamic solver. I am good, Hare Krishna. Thank you. The nucleus is, it's basically like your dynamic solver. I'm just, for these exercises, I'm deciding not to use them, which is why in the hair system shape, I just usually just turn it off and play with the original kind of settings. All right, let's close this one out and then go to, is this a good pace for you guys? Can you guys follow along? Yes, great. Okay, cool. So now I'll show you kind of how this was a project we basically started at Autodesk when we were doing an artist in residency for Slice Lab with my business partner. And we were asked to develop jewelry to be used with the Ember 3D printer. And the goal basically was to create objects of jewelry that needed the 3D printing technology to get made, which is why with the hair, I started using the hair system for this one line, because it has curves in 3 dimensions that in a traditional jewelry making would be a lot harder to build out of wax. And yes, it can be piped in Maya. And this is kind of new to Maya 2017, and that's the bonus tools that we asked you guys to download. And I'll show you I can show you on this exercise, and I'll show you also at the end for the kind of mangrove 3-dimensional exercise. Okay, cool. So basically, just to run you through how the ring was more or less created from its inception. The idea was to create a ring that had layers to it, which would basically create the need for the 3D printing, right? Because that was our goal, is like create something that is for the 3D printer that could only be used with a 3D printer. So started creating layers, then just simple array or tween or whatever you want to do. And then it's bringing those curves into Maya to get you this result. So I'm not going to do the export import because I just showed you guys that in the first exercise. So I'm going to open the setup file that was in the Dropbox. Can these are 75? Let me just check all the questions. Time bar, I think I answered most of them. Cool, cool, cool. Yes, video. All right, so this is my initial set of curves. And I'll just open the final just to make sure I'm using the right settings because this slam jewelry was done 8 years ago, maybe? No, 6. So sometimes I'm a little rusty. Been learning great new things with the Future Leaf fam, so I haven't used my hair system sometimes in a long time. Been practicing my Houdini and ZBrush. Okay, Thanos, no problem. Just ask away. It's a very cool system. I mean, it's I like how it's very organic, but it's also very has a mind of its own, right? So you just kind of gotta let it do its thing and then adjust the setting and like be nice to the system and it'll be nice to you, kind of thing. All right, I'll just turn that to 500. I got my lines here. Boom, boom, boom. Let me see. Okay. All right, let's go to curves. We'll do rebuild like we did. And for this one, I'm gonna keep it on the lower end, maybe 15. And that's the other thing, right? Is I know I'm not gonna be able to get the same result as I had when I first created this rig. That's just because unless I have the exact same file and I'm pressing play and I'm stopping at the exact same frame, it's gonna be different, which is kind of cool about it because then it can also allow you to iterate and have different versions throughout. All right, duplicate this group just so I have it in my back pocket. Boom. Go back to my effects and here, make selected curves dynamic. Cool. And you'll see these things, that's just kind of me having a messy model. So this was later fixed in Rhino by deleting some points and whatnot. Thanos, you're fine with no hair. Look, I barely have any hair. I just have them on the computer. Hair system shape. We'll turn that off again. I'm gonna hide the original curves, what Maya is calling the follicles. Starts with Rhino and imports to Maya. Yeah, I mean, if you're comfortable with Maya and creating curves and everything, you can just do it in Maya too. I've just been using Maya more as like just like how you would use Grasshopper for certain things, I'm using Maya as another tool, right? Because I'm very comfortable with Rhino or with the Illustrator to create the curves. And then Maya, I mean, I love Maya for modeling and 3D modeling and everything. I've done a bunch of work within it too. It's just for the hair system stuff, I like just the curves. I like creating them in Rhino, but that's up to you guys to however you feel comfortable to get the initial set ready. All right, hair system 1, hair system shape. We turned that off. Now let's see what happens if I press play, right? Oh, great. Super fun. All right, I mean, you could pipe this and turn it on its head and say this is some kind of sculpture, right? But we want to, let's see if we can recreate the look of the ring. How are we doing on time? Just to make sure I get to the final exercise, Vamsi, or
We are running on +10, Arthur. So I think you can take another 5 to 10 minutes at max.
5 to 10 minutes at max.
Yeah.
Okay. So then I'm going to switch to the final file of this exercise. Just so I can get to the last one. So this is also in the Dropbox. And you can find it in there, and then you'll see the hair system shape. Here, shape 1 already has kind of all the settings, and you see because of the scale, the static link that we had at like almost 2000 before is now at 13.5, right? The turbulence, the speed is lowered just to see it move a little slower, and then the rest is mostly the same. So if I go back to 0, I'll turn this to 500, and then boom, right? Cool. So now I have this awesome kind of cool looking clinging together set of curves, some of them all clumped together already. And then basically to create the ring from this point, I just went to exported this to IGS, went back to Rhino, and this is more of like my process. You could do this in Maya, you could do this in whatever software you're comfortable with, but then I edited these curves, right, to get the feel I wanted in Rhino by just kind of pulling and like pushing some of these to create the main shape. And then the piping, I did all in Rhino just because with jewelry, the precision of it, you're dealing with 0.8 millimeters, 0.9 millimeters, 0.95 millimeters on the piping. So it's, you kind of have, I kind of needed Rhino because there was a lot of iteration. So once I had the curves, right, I just stayed in Rhino to create the final output. So that's for the ring. Let me know if you have any questions, and then before we close out, I'll just show this kind of final exercise and show you guys how to create the pipes in Rhino directly. That's from like the pipes in Rhino, it's when I don't need as much precision and I'm just doing something like for the image, for preparing the workshop. This, I didn't need as much precision to it, so yeah. And then for the, yeah, just for this was basically just using, for the final, this was just using piping and filling out some of the gaps for the final ring. And if you guys are more interested in the jewelry, I can like, you can ask me any questions because there's a lot of things that are involved in it that are a little more complex. You've got to start adding sprues to pour it. The wrapping on geometry. So the wrapping on geometry was basically done through Rhino by, instead of wrapping on geometry, the curves were created already being three-dimensional and in the shape I wanted them to be in the final output, if that makes sense. For the wrapping, the geometry, what we also used for the bracelet, which I would need to dig a little longer to find the files, to be honest. So I don't know if I'm going to be able to do it. But what we were using is a flow on surface in Rhino, if you know that. So if I do solid, should get surface. Let's go to shaded. I'm just gonna do this really quickly, right? And let's say you have a flat surface and a circular surface for a bracelet, right? Or whatever. I'll just flow along the surface. You say copy usually, auto adjust yes, press on a corner of this and then press on another corner, and then you can start creating like cool effects. I think, whose question was it? I don't know if I answered it. For the flowing on surface. So here, this is the final output, right? And I'll just, so press play. Now this thing is giving you this was generated in Rhino, again, the curve between two planes and just kind of randomized point connections. Right, so now I'm gonna duplicate this, right? Because these are my animated curves. So I don't wanna mess with them too much. Because once I duplicate it, hide, those duplicated curves don't have the animation anymore, so they're static. And I see there's some curves that are just by themselves, didn't do much, so I'm just gonna get rid of them. Bye-bye. And then here, that's the cool thing about bonus tools, is modeling curve to tube mesh. It's kind of like a hidden thing in Rhino for some reason. And then here in the channel box, without touching anything, once you click tube mesh, don't unclick it or anything, because then it's kind of a pain to change them all at once. So here, length divisions, I'm gonna do 30. Width division, yeah, 4 or 5, we can do 10. Just, where's my radius? The width, I'll do 1.5, a little bit bigger. And then the taper is pretty cool. It's from the start point to the finish point. If you bring it up, right, 3, it like tapers the start of the curves to the end. So I thought that was like super fun. That's an easy way to create some kind of cool structure, and that's how this was created, by just using the taper 1, and then in order to create kind of the dendro look you're looking, I tried bringing those to dendro. Personally, what I did is I preferred bringing those into ZBrush to cap. I like the ZBrush remeshing better than dendro sometimes. And Cocoon, I just started using it, but it's a little too slow for me for some reason. Yeah, Dynamesh it in ZBrush, or I use Remesh a lot in ZBrush. I like the look of it too. So yeah, that's, I think, most of it all. Oh, just in order to bring it to ZBrush right here, you probably just want to fill hole, right? So it closes all your pipes. And then you can bring this as like a closed mesh. So that's what I was saying. I didn't merge for this kind of look here. I didn't merge it in Maya. I used Maya and exported this. Let's see, just to have this. Exported this as an OBJ here. And then make sure in order to export to OBJ, in your plugin manager, again, there is an OBJ export. Make sure that's loaded and on auto load. The tube function. So output curves here. Bonus tools. So that's what you have to download. There was a link sent, I think, to you guys. So in this bonus tools and modeling, you have curve to ribbon mesh, which is also pretty cool, and curve to tube mesh. I use the curve to tube mesh setting, click it, and then it's hidden. No, there we go. There they are. And it created more curves again. But then just so you guys see it quickly before I hand this off, if that's okay. Curve to ribbon mesh is pretty cool too, because it creates just basically a ribbon, right? I just want one division in it. I want to do like 15. Then the taper is like how it's the same thing. But then what I just want to show here, and I'll duplicate this. Maybe sorry guys, so hard to see. Two-sided, okay. One thing you can start doing is if you join, this is combine, mesh, combine. If you combine all of those, it creates one mesh, right? And then you can start, and this may be like a future, this maybe I'll do it as a future workshop or something, because it's a whole thing of its own, but just to give you a preview, mesh bridge, whoops, or maybe I'll do append. Where is append? Append to polygon. So if I select an edge, select another edge, right? Enter. Now when I press 3, I can start seeing these kind of curvature happening. And that's how, kind of how this was created. So this would be a whole other workshop, to be honest. So I'm just gonna give you this little preview, and I think we'll, let's do just another one so you can see. Oof. All right. And then you can keep going forever and ever, right? Cool. I'll just save this. Let's do cancel, just save as a new file. Workshop, so you guys can use this. All right. Stop video, stop the screen share. Stop. Let me know if you guys have any questions. You can continue, please. All right, Thanos. I mean, I can keep going, but I think we have, it's time for the next workshop. All right, Vamsi?
Yes.
All right, cool. So I'll
Yes,
stop
Arthur.
sharing.
Fantastic.
Pretty awesome. By the way, the next workshop is gonna have some voluming and piping workflows with Blender that you can even use this model for that.
Cool.
Thank you so much, Arthur.
I learned something. I will definitely be on the next workshop then.
It's
I
pretty
need to know
cool.
that.
Love the workflows, Arthur. I guess Maya is really great when it comes to these
Simulations and
Yeah, the simulation thing is like pretty awesome, pretty fun to play
super
with.
nice and neat rings too. The jewelry were
Thank you.
looking
Thank you.
really
Thank
great.
you.
All right. time for Neverlab with Teddy and Stefana.
Great.
Cool.
So we have not just one, guys. This time for this session, we have a duo, Teddy and Stefana.
Stefana, are you
Hello.
upside down?
Yeah, Stefana was flipped.
Yeah, sorry, I'm having some issues with the camera.
That's totally fine. Yeah.
Yeah.
All right.
So we
Hello.
have, hey.
Christmas spirit, guys. So,
Yeah.
All right. To introduce Teddy and Stefana, Vamsi.
Yeah. So we have Teddy and Stefana, the founders of Neverlab. It's a pretty new initiative, guys. Do follow and support them. You can find them on Instagram at never.lab and Stefana_Zapuc and at Teddy Fadous. So the workshop is called Fluid Branching, and it's going to use Rhino, Grasshopper, and Blender. And so to give you a brief introduction of Teddy and Stefana, so Stefana and Teddy received their masters in IAC Barcelona, complemented professional practice in London, Barcelona, Dubai, and Lebanon with personal research on theories of parametric design, focusing on relationships between architecture and advanced design tools. In 2020, they founded Neverlab, a cloud-based studio, considering the COVID times right now, a cloud-based studio which aims to explore new architecture ideologies of the future. Neverlab, Teddy and Stefana, the stage is yours, guys.
thank you.
Thank you for the
Thank
intro,
you so
guys.
much.
Awesome. Go for it.
So I'm just gonna share my screen and go through a brief intro of what we're gonna do. So you probably, guys, you've seen like the renders that Future Release posted. So this is kind of like what we're gonna achieve with this workshop. And we put together some diagrams and a small pseudocode for you just to kind of break down the logic of the code and to kind of understand what are the steps that we're gonna take. So the goal is to create a branching system, and we're gonna do it in Grasshopper because we wanna keep it quite controlled. So to do that, we're gonna start very simple by having a base plane and a top plane to kind of define like the canopy or the roof of the branching system, and then the roots or the base. Then we're gonna determine kind of a direct connections between the roof and the base. And then to make it more interesting and add a bit of complexity to it, we're gonna populate in 3D all the points that are within this boundary box. And we're gonna use proximity 3D, and also we're gonna use the shortest path, shortest walk plugin to kind of get this complex branching system. And then we're gonna have a short bit of kangaroo where we're gonna use springs to kind of tension and achieve this spring effect on the branching system. So this is one way you can do it. We've been developing like a few iterations of the code. And instead of setting up the base plane, you can also play around with the original BREP that you have and also select points on your edges and so on. And then depending on what you want to achieve with this or how you play with the code, there's loads of things that you can do. And it's pretty fun. And then as Eric mentioned, we're gonna also show another way of meshing the curves, and we're gonna do it in Blender. So this is kind of the compositions you can achieve with those branching systems, which is the simple iteration that I talked you through. And then Teddy is also gonna show you a few iterations of this and kind of like ways to manipulate the parameters and how to play with the code to achieve more interesting results. And we're also gonna go a bit into pufferfish. So I'll go with you guys throughout the basic setup of one branching system. And then we kind of wanna show you how to apply it onto a twisted box to kind of array it and map it in those boxes to achieve different kind of canopies and forms. And I'll go through the rest a bit later. So let me get into Rhino. Cool. So as I said, we're going to start with a simple BREP. And if you guys downloaded the files from the Dropbox, you already have this internalized. But just feel free to create your own VREP. So just don't get too crazy with this. Keep it quite simple. Like just you can create a box and you can manipulate it. Like you can move some edges and just like give it whatever kind of initial shape you want to start with. But for now, I'm just gonna talk you through this one because I quite like how this canopy is created here. So as I said, the goal now is to, from this VREP, to kind of take the top part and the base of it. So for this, we use deconstruct VREP. And first of all, I want to get the top surface. So I'm gonna do a list item and I'm gonna reverse it to get the last item, which is this surface at the top. So unless I want to use the base surface as well, in which case I would add another item here, which would give me the base. But in this case, I kind of prefer taking the edge. So in the deconstruct VREP, I'm going to go into edges and do something similar to this and take the item that gives me this edge on the base. And I want to have one connection point to the base. So that's why I'm going to go ahead and do a curved middle, which is going to give me the middle point of this curve. So now we're going to populate the top surface or roof and then connect it with this point, and then also create this network in between. So to do that, from our roof surface, we're going to divide the surface into points with divide surface. You can also do it a bit more randomly, so you can populate the geometry if you want a bit more like randomness in the points. But for now, I want to keep it quite organized. So I'm just gonna divide the surface with UV count. Then I'm gonna go ahead and from the main VREP, I'm gonna populate the geometry. So that's gonna give me all the points on the exterior surfaces of this VREP. There's many ways to do it. I think Teddy has prepared like an iteration where we populate the geometry in 3D, and that gives us more complex results. But for now, we're going to go through this more simple variation of it. So we have those three resulting points, and I've organized it. So if you right click and you can change here to text to kind of like keep it organized and know what your connection points are. So the roof connection points, the network points, and the base connection points. And I'm going to go ahead to merge them. And this is the basic setup. And then I'm going to jump into our next kind of set of operations, which is going to be connecting the points by proximity and by the shortest walk. So as I showed you in the diagrams, we're gonna, with the line, we're gonna connect the base point with the top point, and that's gonna be our guide for the shortest walk. And to achieve that more complex kind of branching system, I'm going to take point proximity 3D. So I'm going to input all my merged curves here, and I'm going to group them, and you can change this number depending on the number of connections that you want to have. But I wouldn't recommend going too high to kind of not make it so hard to compute. And then in Kangaroo, we have this component here, which is remove duplicate lines, which is also very good practice to kind of remove all the necessary lines for the computation time. So after doing this, we want to remove those top lines because we don't want to have like a straight canopy. We want to guide this shortest path to kind of create more of the this kind of path and not those lines. So to remove those lines, first of all, I'm gonna evaluate the curves, reparameterize it to get values between 0 and 1. And I'm gonna select the middle points of all those curves. And then I'm gonna go ahead and with pull point, so from my roof surface here at the beginning, I'm going to input that as a geometry, and the points to pull would be those midpoints from the evaluation of the curve. So the goal with that is to call the pattern of those lines, as I said, to remove all those horizontal lines at the top. So for that, we have this call pattern, and we're gonna test it against the distance from those pulled points that are at the top, and this value, which you can also play with to kind of determine how much you want to remove. And we're gonna input it in our curves, and with this pattern, we can see how we've kind of gotten rid of all those top horizontal lines. So with this setup and with the guide of those direct connections, we can go ahead and use the shortest walk, which is a very cool and quick plugin. And we're gonna feed our call pattern into the curves and the wanted path, so kind of our guide with the direct connection. And we get this branching system. So now we kind of want to make this more smooth and organic, and we're going to do a very quick kangaroo simulation to do that, to kind of add like strength and tense those curves. So in order to do that, we're going to be using Zombie Solver, and that's because we don't really want to keep resetting the simulation like it's normally done in Kangaroo, and also we're not really interested in all the iterations. We kind of just want to have the final result. So we're gonna put our zombie solver, and then we're gonna have to put here our 4 kind of goals for the kangaroo. So the first one would be to show our curves. Then we're gonna get the length line, and we're gonna explode those curves and feed the segments into the length of the line. And we want this to be 0, so we can strengthen them as much as possible. Then we're gonna need a rod, and we're gonna play with the bend strength and the axial strength of this. And then we're gonna need an anchor, which are gonna be the end and the start points of our branching system. Again, like we removed the duplicate lines, we're gonna remove the duplicate points, not to kind of have too many points to compute or any duplicates that we don't need. And we're gonna feed this into our anchor. And with all of those merged, we can then just feed it into our zombie solver. And that's how we get our want to organize the curves. And so maybe a better way to show it is here. The output of our curve network is 88 values. And once we go through the process in Kangaroo, we can see that our output is 5,700 curves. So we don't want to take all of those values further. We want to measure the length of the list here, so the 88 values, and split the list with this index. So then in the end, we only have those 88 values. So that's the basic setup. Would be really cool to see what you guys, kind of how you play with those values and what BREP you start with. And now I'm gonna pass it on to Teddy, and he's gonna show you the pufferfish part, and also he's gonna go a bit through the beginning of the code and show you how to alter some of those parameters to create some fun iterations.
Okay, hello guys. Can you hear, see? Yes, no?
Yep, all good.
Okay, so let's start. First, I want to go back to the beginning when we set up our BRAP, which was in the bottom, it was 1 point. And in this case, I don't want to use it as 1 point anymore. I want to have here as a base more than 1 point. So the branching will end up not in 1 column, but more than 1 column, which is in this case, this one. The case before it was 1 point only, which is here, okay? So mainly we want to have the bottom and the upper surface as a surface. So therefore we can populate those points that they are going to be our anchor points later on, or our connection points. Moreover, for more complexity, as we see, populate geometry only populates surfaces which is outside, not the inside. It's not a 3D. So what we did here is populate geometry on the BRAP itself, and then cull whatever is outside this BRAP by point in BRAP. It's a component that you can find in Rhino with no plugins, as well as the cull pattern. So we don't need all of the external points that are exterior than from this BRAP. So after that, we need to also change this path, which is the wanted path, from a simple line path to a cross-referenced lines. So all the points to all the points. In this case, the base point is 2 points here. So as you can see, we have 2 points, which are the middle of the first edge and the middle of the second edge. Or we can transform it to here to have it the base connection points as more than 1 or 2 points, which in this case they are going to be 10 points. Okay. So here only by changing this, as we can see, it's gonna take a bit of time because it's gonna recalculate everything. Maybe I did something wrong. It's fine. We can wait for it 5 seconds. Oops. So as you can see, guys, the code is very oof. Okay, just a second. Sorry.
Try disabling as well, like
Yeah, that's
the
what I
next
forgot to.
the next steps. So maybe you can mess around with it a bit more.
Yeah. Anyway, we have time. No worries, guys. Oof. Stefana, maybe you can keep on going until I stop.
I guess just crash it and start over.
Yeah, maybe just restart it.
It's totally fine.
It's back here. Okay. So as we saw, it's a complex thing here. So the wanted pass from the simple one of Stefana was like this. Now it's gonna be more toward more points in the bottom. So in the end result, we're gonna have more complex shape heading toward more than one connection point in the bottom. So in this case, after kangaroo, we have the curves themselves that we need to bend or relax more toward a better smooth and more relaxed curves. In this case here, this part of the code you don't have, guys, okay? In this part, we are transforming this polylines, which of course I'm gonna share again. It's transforming these polylines into curves, more curvy polylines. So it's a very, very simple thing we did. We exploded the segments so we can get the vertices of these segments, and then the NURBS curves will allow us to have those fillet between those points. And here we set up the degree of those fillet. Moreover, now before I go to pufferfish, I just want to show a trick that we can get from these curves and these points, and these polylines together. So in the beginning, we have this simple polyline, and after this, we have those curvy things. So why not lofting them together so we can have a better or cooler shape that can be more dynamic structure into the nodes of those surfaces. So what I did here is just a simple list trick. So we can see here that this list is made of 3 components or indices that we don't need. So therefore, we can get this output from merging 2 curves is the first curve that I'm gonna loft with and the second curve that I'm gonna loft. So for me to achieve this, I need to simplify this this component, which is the curves that I got, and also as well simplify the other one from here, and of course graph both. So then we can have this tree of 2 curves, set of 2 curves. So those set of 2 curves, once we lock them, we're gonna have this loft in between 2 curves. So it might look cool once you're gonna explore more what you're gonna achieve with this result. Okay, again. So we're not gonna go through this. We're gonna go through the pufferfish and how to generate this kind of curves into this space, which is having the same structure repeating itself. First of all, this is a semi-arc or whatever SP line you're gonna draw. You can draw whatever you want, okay? So therefore you can achieve whatever you want really to achieve. So now just a quick overview of how pufferfish works, or how bounding box morphing box works. Okay, so first we have this box which we generate. In this case, we are using the twisted box component. In this case, it's old, but it's not. It's everywhere in pufferfish. If we go there, here, this is people, and this must be pufferfish, and this you can find it here, guys. Okay, it's a twisted box curve variables. Okay, so anyway, for us to set up this curves, we must understand what's happening here. So we need this bounding box, which is the bounding box of all of my curve, to go inside this twisted box. Okay, so first of all, what I need to do is to group all of these curves, because now we have 1,210, and here we have one group only that is gonna be bounding box the whole group. Okay, we go through this again later. Okay, so now we have the bounding box. I need to construct my twisted box curve. So what I need to achieve here is, if I have this curve here, which is my case, I want it to start from 0 or from 60 to 200, and then go to 60. What's 60 and 200 here? They are the length or the xy of the box that I'm gonna aggregate. Okay, so here again, sorry for this, we have this curve and we have this box here. Okay, so for me to be able to play a bit with the variables here, I need to understand what's happening here, or what is it asking me for. So if first I want to introduce the twisted box curve, it's gonna ask me for curve for parameter t and for the size xy. These are the ones that are the most important to understand. Why? Because the t parameter is the distance between each division of this curve. So for me to be able to do this division, I need to set up a parameter that goes from 0 to 1. Okay, so my curve parameter t is gonna be the distance on the curve itself. Sorry. As well, I need to understand where's the xy coming if this is the t. So the t is gonna be representing like mainly the x, and this here is the z of the box, no? But different other than that, pufferfish told me that okay, these are the t's, and the xy are going to become those ones of the box. This is x, this is y. Okay, this is t. Let's not forget. So this is like that. Okay, I will be more than happy to explain it again and again and again, but this is very important to understand. Why? Because we did this trick here, which is the rotation of the bounding box. Okay, so now I have a bounding box, which is this one that we are seeing now on Rhino, which is this. So this one, oh, what did I do? Okay, it's gonna, I moved it by mistake, sorry guys. So my main point is this xy is different than this xy of the curve. So what we need to do is to rotate this bounding box to best fit the xy of the curve, which is the bounding box curve variable. Okay. Let me maybe go to the questions. Okay, thanks, Stefana. By question, it's not the file to download. Yeah, I'm gonna upload it again. Oof, sorry guys, this is gonna take time. As you can see, the file is very heavy if you play in the wrong way. Come on. Okay, back. So whatever we did here in this variable, first of all, I need to set the curve, which is this one. And then later on, I need to play more with the size XY, okay? So I need here in this XY, which I already told you, it's this one and this one, the up one. I need to say that, okay, from the beginning of the curve, so from here to the middle of it, I need it to grow from 60 to 200, and then from 200 to 60, which is the length and width of X and Y, okay? As well as parameter T, I want it to go like this more than 1, which is the offset. So I wanted to make it more smooth or more into under a graph mapper influence or something like that. Okay, so mainly I set up the first domain, which starts from 65 to 150 in this case, not 200. And this is the range that's gonna come in the beginning of X. Okay, so this is the first half. What did I do in the number here? I set the number of the T parameter divided by 2. So again, the T parameter, if it's 20, is 20's division into this curve. So what I'm saying here is, okay, take this range, which is, take this domain, which is from 65 to 150, take the first half of the 20 division, and make this range as a list that goes from 60 to 250, okay? The same goes to the one that goes from 200 to 165. So here, as you can see, they are inverted. So it starts with 150 and ends with 65. So this is the XY parameters that we have here in the end of this merge list. So if I check here, it's gonna from 0 to 19, it's gonna go from 65 to 65, and it will go to the maximum, which is in the 10th or in the ninth. The ninth and the 10th are okay. So to 150. Again, what I need to do is to reparameterize those numbers, 20 subdivision, into, as I said, this graph mapper or this shape, which is going wider and then going, okay, maybe I forgot to talk about the rotation. The rotation is easy. If you need to do rotating this bounding box along this curve, you can just set the rotations here. But in this case, we don't want to play with it. And for the weighted, it's always on. Okay, guys? So mainly here we have the twisted box already parameterized, and we can play, as I mentioned before, a lot with the parameters. The goal here is to make this twisted box component as much as parameterized as we can, so we can play more, or it could be more playful. So again, the bounding box of this is different XY of those XY that we have here. For this reason, I rotated once on YZ and once on XY. So this is the new bounding box for me. So it can get we can get a seamless pattern out of those bounding box. Okay. Here I'm just gonna test for you guys what's gonna happen if, in case I didn't rotate those bounding box. Okay. So in this case, if I just said that I'm gonna use the same bounding box and get it here to the to this one, you're gonna see that the XY is going through the curve, so it's not the XY of the bounding box. Okay. Sorry guys if I'm going again and again on over this, but this is very important to understand. And I don't know actually if I explained it well, but again, I am available, me and Stefana, whenever you want to go over this again and again. Okay. So what we did here, When we finish this, we ungroup so we can deconstruct those points, and then we project those points so we can get another structure layer, which can be here in this case. And as well, so now this is a simple pipe component from Grasshopper. But maybe now if Stefana jumps in to more explain better why we are piping those, so therefore we can use them in better way in Blender and what we are going to achieve in Blender. So yep, there you go, Stefana.
So yeah, we're gonna jump. Maybe you can keep your screen shared, or it's not necessary. But I'm gonna jump into Blender super quickly. It's not gonna be very complicated, but we just kind of want to show like another workflow. So obviously you can mesh in Grasshopper. You can mesh in Maya, like Arthur showed us previously, but we want to show you like super quick trick of how to also mesh in Blender. And I'm going to share my screen. So for that, we played around with the few iterations when we were preparing the file. And for the import, the radius, we found that good values are between 1.5 and 2.5. I mean, feel free to explore, but be careful not to crash your computer. And let me jump into the presentation to see what we covered. Okay, Teddy covered this. This is kind of like as an extra. We recently got a 3D printer and we're very excited about it. And we started printing some of those structures. So we were actually thinking kind of like as a bonus of this workshop, if you guys start posting and sending us like all of your results, we can actually like 3D print some of them and share them with you, which would be like really fun to do. Okay, so I'm gonna jump into Blender, and then I'm also gonna go a bit into like architectural application and this project that we did together. Let me go into Blender and show you this trick of how to mesh it in a more kind of organic way. So open your Blender, and also we just uploaded on the Dropbox. We uploaded, I think, 2 or 3 OBJs for the mesh. But otherwise, if you guys came up now during this session with your own kind of structure, just bake your result and export it as an OBJ, and then we can jump straight into Blender. So I'm just going to delete everything I have here. I'm going to go to File, Import, OBJ. And I'm going to do this exercise on one simple branch first, without the pufferfish. But depending on how we're going with the time, maybe if I have time, I can also try to do it on the whole structure. So I uploaded those on the drive also. So if you guys want to use those or yours, feel free to do so. So I'm just going to import this. And first of all, I'm going to go here into transform, and I'm just going to put it 0.1 because I don't want to have it too big. And it shows up here. And also like kind of a trick or just a thing to mention, like in Blender with exports and scale, if you're having issues, you can also go up here to this little arrow into view. And sometimes you might need to play with those clips start and end, which is kind of like the lens of the camera. So if you can't see your object, you can play with those values. So maybe your camera needs to go bigger, but in this case, we're fine. So just gonna leave it as it is. Cool. So what I'm gonna do now is very quick fluid simulation. So for that, I need my branching structure, and I'm also gonna need a domain. So I'm gonna go ahead and do Shift A to add, and I'm gonna go ahead and add a mesh cube. I'm gonna press scale and scale it somewhere up to 20. Cool. And now I'm going to press Z and go to wireframe so I can see what's happening inside. And now what I want to do is kind of fit this object inside this bounding box. So we can kind of tweak those values here. You can also use shortcuts, so S and G for moving. But I'm just gonna quickly kind of like set this up here within the bounding box. Then let's see how it looks here. Just gonna have to move it a bit. Scale it again. And in top view, looks all good. Cool. So now we're just gonna have to set both of them as in a physics simulation. So I'm gonna select my branching system and I'm gonna go here to this little icon, which is physics. And I'm gonna go onto fluid. As a type, we wanna set it as fluid again. And I'm gonna initialize the volume as a shell. And that's it. Now we're just gonna select our box. And still in physics, we're gonna also attribute this as a fluid. And here as a type, we're gonna set it as a domain because this is like the bounding box within the fluid simulation will happen. And now this part is very important because usually fluid simulation, you kind of just play it and it runs as a simulation or an animation. But in this case, we don't really want to do that. We just want to have this immediate result of this organic meshing. So I'm going to change the end to 1 of the keyframe. So then my start and my end keyframes are the same. So my simulation is going to be instant and not played throughout the keyframes. And I'm going to have to do the same thing here. So in your fluid settings, your end is going to be have to be the same as the time start, which is going to be 0. So now we're just going to get this instant result. And that's basically it. Final resolution is default set to 65. So I'm going to test it out like this for now. So if you just go down here to bake and you bake this, we already have something here, but I kind of want to add a bit more resolution. So a way to do this is first of all save, because there's very high chances like when you mess this number up, your computer might crash. So just gonna do branch test 1, save. Then just gonna kind of slowly increase this number until I have good result. And you can see it calculating here. And we're already, so if I go back to Z and material preview, we can see we're already getting like better resolution. Just gonna hide my initial object. And I'm gonna give it an even higher value. Let's try 250 maybe, and bake. And it's gonna take a bit to load. Oh, so yeah, you can see like depending on this value, and also it's quite important, as I mentioned before we export it from Grasshopper, you can get this like break in the geometry, but it's just a matter of adjusting those values. And now just to kind of get a smoother result, you can go up here into modifiers, and you can add a modifier and smooth it out. And you can play with the repeat value. So kind of just like slowly increase it until we get this nice smooth branching system. And also we can also, so once we're happy with kind of how our structure looks like, and we don't really want to modify it anymore, we can apply those modifiers here. And also I want to kind of get rid of this faceted look. So I'm gonna hit tab, which will take us into the edit mode of this object. And I want to select my faces. So I can either do that up here, which is this third icon, or also I can press 3 on my keyboard and A to select all my faces. And then I'm gonna right click, subdivide. I'm gonna get this little icon here and let's say like 3. So you can see how the resolution of the object starts to get better. And you can up this number depending on the kind of final resolution you want to get. But let's just stick with this for now. I'm gonna get out of this with tab, and you can further smooth it out if you kind of want to achieve this nicer, smoother look. So this is quite an older version of doing this. There's something I think quite new in Blender, in the latest version of Blender, which is called voxel remeshing. So I think that didn't existed, and this way of fluid simulation was kind of a way to do that. But I still find it quite fun to kind of play with. But let me also import the other one. So this was the 2.5, I think, diameter, but let's also see like the 1.5 branch. So I'm just gonna import it. Here. I'm gonna scale it again. Cool. And let's see, kind of like compare the two methods. So if I select this object and go up here and go into sculpt mode, you also get like some cool brushes that you can play with, kind of like ZBrush, but that's not really the point now. So up here you have remesh, and you have the voxel size. And here's where you input your value. So let's try with 5 maybe, and remesh. And I think that's too big, so let's go back and maybe try with like 3. Yeah, so you're getting better results now. And again, you can go to the modifiers and smooth it out. You can repeat this operation. You can also go to edit mode and subdivide it and so on. It's just a matter of like kind of subdividing and smoothing it out until you get a nice geometry. And also one thing that I kind of wanted to show you. So now we've exported this geometry as a mesh from Rhino. But there's also this plugin which allows, because normally like Blender allows you to import meshes, but if you go to edit and preferences in your add-ons, there's this thing called DXF, import AutoCAD DXF format. So if you download and enable this, then you can import curves from Rhino if you export them as a DXF. And then you can kind of play with this workflow. So let me just show you very quickly. So if we add a curve, Bezier curve, let me scale it up a bit. So you can kind of go in between curve and mesh in Blender. So to do that, first of all, let me go into my Bezier curve here. And in my geometry, I can give it a depth. So just a bit like this. And I can also have this taper, which I think Arthur also showed you something similar previously in Maya. But if I have another curve, and scale it up a bit. So I can use this kind of as a reference to determine different thicknesses of this curve. So if in here, the taper object, I will select, this one here, and I select this curve. Now, if I select this reference curve, go into tab and play with those control points, you can see how it's starting to affect like the overall thickness of my main curve. So that's also something that you can do. So for example, if you want to import just your curves from Rhino, or you have like a curve drawing and you want to mesh it in here, you can also do this kind of thing. And then also it's important to know, so let me get off tab. Here, if I go into physics, I don't have the fluid, and that's because it's still a curve. So to change that, you just go to object, convert to mesh from curve, And now we can see we have it as a fluid. And we can do this operation as I showed you before. So this is kind of just like a small extra thing. And I don't know how we're doing with time, or I don't know if it's relevant for me to go through this kind of thing, which is the pufferfish, but honestly, the workflow is the same. So you can, I think here I played with something between fluid and also the thinner one. I exported the geometry from Grasshopper with like a thinner radius. And you can kind of start overlaying them and moving them a bit up and down to get this nice layering of very thick organic canopy with like very straight branches underneath. And this is rendered in KeyShot. So yeah, that's about it. That's the workflow. And then here, just a small like application. We developed this project in IAC for our masters. And we developed this branching system, which we applied to the Camp Nou Stadium in Barcelona. Well, the script is way more advanced because instead of piping it and kind of like making this organic geometry on those curves that we had from Grasshopper, also in Grasshopper, we created a profile curve and we kind of rotated and arrayed it all throughout those curves. So I don't have a close up here, but we kind of got like quite an interesting geometry and quite controlled geometry on those curves. So this is more kind of like what the application is or what you can do with it. But for now, we wanted to just make it as a fun, small exercise and kind of jump from having very controlled branching systems in Grasshopper to achieving more organic things in Blender. And I think that would be it.
Yep. Thank you, Stefana and Teddy.
Thank you, guys.
Super interesting.
Yeah.
Thank you guys for having us. And thanks everyone.
My pleasure.
Thank you.
And our pleasure.
Pedro, it's the best comment, huh? Pay more attention to Blender, guys. Blender is
it's true. It's true.
It's insane.
It's coming to kill all other software.
Fancy. Wait for it, man. Render, construction, design, mashing, remashing, todo.
Yeah.
So yeah.
It's been amazing. It's been amazing. All right. Thank you so much again. Guys, if you want to support Teddy and Stefana, it's at Neverlab on Instagram. Check out their work.
Never.lab.
Stuff. Yeah, never.lab. All right.
Thank you
I
guys
guess
so much.
we made it.
Thank you, guys.
Thank you.
Thank you.
Ciao.
I guess we made it to the last workshop, guys. Arav, are you here?
I think he's here, yes.
All right.
And thanks to Stefana and Teddy, they also reset the clock by 10 minutes. We got back on track.
Exactly.
Yeah.
All right. I guess we'll start a party at the hour if Arav doesn't go extra.
Absolutely.
All right. All right, Arav. We have to introduce you first before we can't. Just a second. Let me give you. You need to unmute.
Yeah, you're muted, Arav. All good?
Yeah.
Yeah.
Are you unmuted now, Arav?
He's still mute. Okay. I will ask him to unmute. Yeah. He's there.
Yeah.
All right.
Perfect.
Awesome.
So,
thank you.
Yeah. We have Arav here, and this is our final workshop for today before we head to Sanzar for the party. And to well round the whole session, the three sessions that we've seen today, Arav is going to take us through Unreal Engine, where you guys can work with all the meshes or the pavilions that you developed in the previous workshops, and you can bring them into Unreal and also create a visualization scene. We'd love to see it, guys. If you do something like that, please share it with us. So getting to giving a bit of background about Arav. Arav is an architect from India, working for 4 years after graduation on projects ranging from commercial, institutional to transportation sector. His interest in Japanese metabolist movement led him to the Hyperbody studio at TU Delft to learn kinetic application and architecture. After getting an opportunity to learn and curate a VR experience for the Y Factory studio MVRDV, he started working towards projects that lie at the intersection of speculative design and virtual environment, delivering an interactive experience. In 2020, Arav joined the architectural office ZJA in Amsterdam, specialized in sports, leisure, infrastructure, and public transport, while furthering his research into cyber physical interactions with a focus to create VR environments for assessing design decisions and client involvement. The stage is yours, Arav. Go for it. Arav? You're muted again. Just a second.
Yeah, thanks. I was muted again. Okay, thanks for that introduction, Mansi.
You're welcome.
Okay, yeah. Okay, guys, let's get into this Unreal world. Yeah, I've been working. I'll just put the video off right now because I'll just put the video off right now for myself because Unreal is quite heavy and
yep.
I have to enable screen sharing, Ramsey. I can't.
Just a second. Eric, we need to make him the co-host.
He has it.
He has it. Can you do it now, Arav?
No.
Eric, he has logged in with 2 accounts. We need to give him the co-host for the second account.
Right. Okay. Can you try it now?
Yeah. Okay. Yeah. Can you see the screen?
Yes, we can.
Yep.
Yep. So I basically assume that there are people here who are familiar with the software, right? And probably know good about it and everything. But I also assume that there will be people who don't really know about the Unreal Engine. So I'll just start off with a basic introduction of the software. Like what's Unreal Engine, why we are using it, and how we are going to use it. So Unreal Engine is basically a game software to start with, right? And it slowly spread across various disciplines like architecture, film, television, etc. Why do we use it is a big question about Unreal Engine. For example, in my office, people just wonder why to use this engine when I try to push this agenda across in my office environment. But people might ask, is it just for still pictures? Like, this is not my work, by the way. It's just an example I found, and it's quite nice though. So yeah, do you use it for still picture or maybe just 360-degree pictures like these, which are truly amazing? I feel you can really feel the environment around. Or you can create these kind of animations and interactive experience. This is my work, and basically I created this with my group for the Y Factory MVRDV. It was like a Sky City experience, and people could just come in the VR world and fly around the city and talk to each other. It was really amazing. The next thing is, or you can actually use it. You can actually use it to create really nice these kind of things where this is like a pavilion, and they actually put this 3D model at a live space, and they're analyzing it to make the pavilion itself steam bending across the lines. So that's quite interesting, and also for me. Now, how we are going to do it is that I just took a small part of it, which is called world building. And I found this interesting because during my initial stages of using Unreal, I used to have a lot of problems because I could create the buildings, and texture it, but the environment itself was quite tricky. And it basically takes a lot of time to create assets for it. But what I'm going to show you is, first of all, how to create assets, how to compile assets over time. In your file that I've given you, basically we are going to use free assets from the Unreal Engine marketplace, and you can do either make your own assets, right? You can create your own textures and everything, but it takes a lot of time. But a good, I think, way of dealing with this is like you can just download free assets every month. There are just free assets everywhere, and also every month Unreal adds extra assets for free. In the same way, in the file that you will find that we are going to use this asset, which is right now for 10 euros, but I got it for free again. And the next one was, so here, the Meadow environment, which is again free. And this one is actually 50 euros on the net. So yeah, it's quite important to gather these assets, but as you can see, I've been gathering them for 2-3 years, and it takes time to build up your own assets for all your game environment. And it's a good idea to just go time and again on the Epic Games website and see, okay, what's the new assets there, and just download it. Just download everything you can find. I'm pretty sure it's going to be useful. Okay, so this was a short introduction. I will now jump to, can you see the screen? Hello?
Yes, we can, Arav.
Okay.
All good. Yeah.
So I'm just gonna say quickly what we are gonna do in this course. So I will first set up a basic landscape, right? Then we are gonna go through these lighting effects, that how to really light up your environment. After the lighting, we will create a basic terrain generation. And when you have the terrain generation, we will put this pavilion. I used the pavilion that I made with my group during my MST one time masters. And I use this pavilion because it's a really fluid pavilion, right? So you can actually learn from this pavilion because you have to model the terrain around it. So that's a good experiment actually to use. The next thing is you do detailing around the terrains, adding waters and everything, and again adding lighting around the terrain. The next thing is terrain painting. So basically adding all the flora and fauna, the rocks, everything. And the last thing will be just to take screenshots, really beautiful screenshots of the out of the engine. I'm gonna now move to my Unreal model itself because I'm gonna close this one because it's quite heavy and I don't want to use that. So I'm basically gonna use a new Unreal Engine file. Okay, let's get ready then. Just a second, guys. I'm just gonna open up a file. Yeah. Okay, so I'm not gonna go through the UI and everything, but in the content folder, you will find everything that you need, your assets, and you will save all your files here. So let's go and open a new level. A new level is basically like a new file that you will get. So here is a new level. What we'll do is, I assume that you guys know how to scroll around and everything because it's just like a game, WSAD, QE is up and down. The next thing what we need is we don't really need the floor and everything. So we're going to delete the floor. We don't need the sky sphere because it's pretty normal and a bit ugly. So I don't need that. I'm just going to delete the sphere reflection capture because we don't need that either. So the next thing we need is a landscape, right? So generally it's in modes. Modes is here. If you're using 4.25 version or 4.24, modes would be somewhere over here. But anyway, go to modes, hit the landscape button. Yeah, so here is your landscape. So here you can see the landscape. Now, if you remove the details a bit lower, you will find that you can modulate the landscape over here, right? The most important thing is first that just make sure that everything is zero. For example, my Z value is not zero here, so I'll just put it to zero quickly. In the model I've provided you, I think it's 255 by 255 quads. But for this exercise, I'm going to use 63 by 63 because I don't want my computer to freak out online on Zoom. And what we're going to do is we are going to quickly zoom it to 200. We're going to scale it by 200. What it means is that what it says is that 63 by 63 has an overall resolution of 505 and each one pixel is equal to 1 meter, right? So we are essentially working on a 500 meter by 500 meter scale. And by scaling it twice the scale, we are now having a 1 kilometer square site with us, and which is quite nice for this kind of an exercise. Although in the exercise that I gave you, it's 2 meter by 2 meter. So into 2, that's 4 meter by 4. So that's even bigger. So you guys can play around with that. So after the material, you just do create, and that's it. Your material is created. Now to go out of the mode, you just have to go to mode and go to select. You're out of the mode. A good experience is, as I've experienced, to just this can be getting cluttered pretty quickly. What this is you all the elements that's inside your editor, you can find it here. So generally just create a folder. Okay, I have lighting, for example, and I know my fog is a light, so my light source is lighting, skylight is lighting, so I'll just put everything inside. Next thing, I'll just again create a folder and say landscape. The new landscape I have created will be inside this folder. Okay, so now that we have created a landscape material, this is the landscape base. Let's create a material for the landscape. So let's go, just select the landscape button and just put the details button up and down. Here, if you go down, you can control a lot of things. Again, the scale you can control from here. You can create different kind of materials for it. And here you will find material. Now for this, like I told you, we will be taking reference from the different things we have downloaded from the Epic Store. So here we have the Brushify. We'll be using the Brushify materials for it. So it was created by a guy who has actually worked for Epic Stores, and he's a really amazing guy. He has created these really light shaders, which really work with really well with the landscape elements. So if you go into the material palette, you will see landscape. Then you have the MI landscape and M landscape. The different, if you hover around it, you will see that one is a material while other is a material instance. So, I mean, how do I explain it to you? So basically a material is where everything happens. Like if you imagine Grasshopper, right? All your functions are happening inside this material editor. So I'll quickly open it. So to start with, you have your basic metallic, specular, base color. You have all these things which you can control, and all of these are your functions. While if you create an instance of it, this will have all the parameters that you can control. So that's why what an instance is. So we will take the instance here because we want to control all the parameters easily. And to hook it up to your landscape material, all you have to do is select your landscape, select this button, and that's it. Now, if you see that it's all black, right? You'll be wondering, where is the landscape? The thing is, this is not a very generic landscape material, right? It's made up of multiple layers. So what you need to do is you need to switch on the layers. Now, how do you switch on the layers is you go to modes, you go to landscape. Once you go to landscape, you have these three things: manage, sculpt, and paint. You just go to paint, right? Just do details button down and you will see all these paint layers are here. So basically in this layer, you will have grass, desert, forest, snow, beach, dunes, everything. So to put one on, you just have to select here, and here Unreal will already detect if it has a layer info or not. And this already has a layer info. So you just have to select this and boom, you have your grass in it. So if you go down, you will see that it's actually quite detailed grass. You see here. So it's mostly like Twinmotion has some kind of these things that, okay, you just pick and drop a thing. But the problem is that in Unreal, you have to actually build your assets over a long period of time, or yeah, it's quite time consuming in Unreal. The next thing is that we see that we do have a nice landscape now, but we have a lot of lines on it. So how do we move? How do we deal with that? So the first thing we need to again go out. So we know that there is a lot of shadows. That means there's a problem with the lighting. So let's go into lighting and let's see what each of thing is doing. A good thing to do is just click on everything and see what's happening inside this detail folder, right? So when you see here in fog, in mobility, there it's movable. While if you go to light source, it's stationary. So let's do this movable and you see that, okay, it's gone. So also the skylight, do it movable. Now the difference between stationary lights and movable lights is that stationary lights, only the brightness and color can be changed inside the Unreal, while the lighting maps has been baked. So basically the lighting won't move and it won't interact real time. While in movable lights, it actually interacts real time. So that's why it's a good idea to put all your lights to movable. It is quite intensive for your computer, but yeah, in these kind of things, that's how it is. If you want to put your cursor down a bit, you can do this. It will slow down. That's also a good idea if you really want to zoom in and everything. Okay, so now we have this kind of a patch of landscape. but there is no sky like you see, right? There is nothing around. So let's build some realism around. Let's start with fog. And how do you place things around is you go to place actors, it's here, and just search for fog. Now we already have an atmospheric fog. Let's get an exponential height fog. And the first thing you need to do is just bring everything to 0, 0 location. So what you need to do is you need to click this small tick around here and just it gets to 0. Now, basically the idea is that we need to tweak these numbers so as to bring in a gradual gradation between this light and that light. And also the fog is quite a lot right now, and we don't really want that. So I have the numbers already with me because yeah, it takes time to tweak it. It takes a lot of hit and trial error. But for now, I will just hit the numbers that I already know. So I know this is 0.005. So it goes all the way back. And if I do this 0.01, there, you see now what we wanted was a gradual gradation between the horizon and the sky, and also a fog that's not so harsh. Next, like you saw, we don't really have clouds or anything, and that's not gonna cut it. So let's get a cloud information. You will get, again, you will use the brushify material for it. Just go to brushify, material, sky, and here you have a lot of domes, right? So we will be using that sky dome. Just bring it in, and okay, it's in. And again, whenever you bring something in, just make sure that okay, it's 0, 0 located. But yeah, it's not there. It's quite small actually, and you can't see it. So the F key will actually zoom into it. So just put F key and put it down. Okay. So since it's really down, let's increase the size. I think it's just say try with first 5 zeros, and let's see what happens. Yeah. Yeah, I think I'm quite happy with this number. Yeah, but now you see that there is a huge shadow around my landscape, right? That's because the sky dome that we just put is actually, we have shadows on. So we need to look for the shadows around here. Just go to lighting, just hit the sky dome, go to details panel, lighting, and click the cast shadows off. Also, just check whether the mobility is movable or not and select the movable button. Okay, so now we have all the elements in, ready for the lighting. So take the sky dome, exponential height fog, and take it to lighting. Okay, select the landscape off. Okay, and now a good thing to do is when you calibrate lighting is to actually put everything off. So just put your exponential height fog off, your fog off, and your light source off. Yeah, so now you see that, okay, this is just your sky dome. That's it. This is just your sky dome. So this is how it actually looks without any other thing, right? So this is a very good way to start calibrating your lighting, because if everything is on, you don't know how everything interacts with each other. So just put your skylight on and your sky dome on. So the next thing we will put is our fogs on. So now you see that this is my fog, and it's really not interacting well right now. You can see that it's a bit harsh over here, the red lines that you see. So that's because of the sun multiplier. So just put this down to 0.05. I have already checked that. So that's why I know, but you can basically tweak this number and you see this. It's basically sees, okay, what's harsh and what's not harsh. So that's 0.05. And then let's go to exponential height fog. What the height fog needs to do is it basically, again, needs to do a gradual gradation between your horizon and your sky. So generally it can be like this, it's also fine, but it can also go a bit dark. So like this, so that you see a bit more of the cloud on the horizon. Yeah, something like this. So that we just get to see a bit of the clouds on the horizon. Yeah, I think I like that. Yeah, so it's basically the whole idea is to blend in the whole fog and the sky dome together. Next, whenever you change anything in the lighting, a good idea is to go to the skylight. This is the skylight, and you need to recapture every time. So if you hit recapture, let me show you what will happen. So you see recapture, and the whole thing got lighted up a bit more. So whenever you change any of the numbers in your sky dome or fog or light source, go to skylight, hit recapture again, because it doesn't do it real time. It needs to recapture again and again. Yeah, so now let's see where the sun is. So basically our light source is the sun, right? So yeah, okay. So check if the sun is at the center, just center it. And if you use W, you can actually move it around like this, but we don't want to. If you go to R, you can scale it. If you go to E, you can rotate it. So you can just check where your sun is, because right now it's up in the sky right at 12 o'clock location, I think. And you can just move it around and see where it is. The idea here is to match up with behind over this. We need to match the sun with the sky dome, right? So just bring it down a bit, and try to match things with it. Yeah, I think this is about where it should be. You can see the shadows. So somewhere over here. Once you have put this with, yeah. Okay, so I think that's good. We have now calibrated the sun with this. Also, what you can do is with the light source, you can change the color gradation a bit so that you can match the yellow light which you have over on the horizon and the sky dome. So just match the sunlight with it. That's it. So let's save the map before it crashes or anything. So I'm just gonna put it in the live map. I'm just gonna say 0, 1. So this is the first steps. Now a very important step that you will see is if you go up and you go down, right, you will see that it's changing. It's changing the contrast a bit. Right now it's darkish. When you go down, it's really white. So you really don't want that. This is something that we want to avoid. So in order to deal with that, we need to bring in another actor. So let's go to this. It's called the post-process volume. So let's bring it here. Again, you have to zero it always. Let's go and see where it is. So, oops, yeah. So here it is. But the problem is that anything you do inside this volume, it will only, anything that you change here, it will only happen inside the volume, right? So you need to make sure that it happens everywhere. So you need to go down, find the post-process volume setting, and there's a option here called infinite extent. Just select that, and now it will happen everywhere. So what we need to do is we need to make sure that the contrast doesn't happen like how it's happening now. We need to make sure that it's equal. Everywhere we see, we don't have that change. So just go up and let's go to bloom, right? The first thing is bloom, and you change the intensity. This should be 0. The next thing you need to do is you need to come down to the camera. Oh, sorry. Yeah, it's here. You need to go to exposure, change the metering mode to auto exposure basic, exposure compensation. What's it doing is it's compensating for the exposure. So basically you look up, it's compensating, again it's compensating when you look down. So just do that 0. So it does get a bit darkish, but then it's still happening. That's because we have minimum and max brightness set to different values. So just do the same value, and now it won't happen. So this is something that's really nice if you want to add that extra level of realism to your scene. Okay, so we have added the sun dome on, we have added the color, which has a bit orange. Now, a good practice is again to loop. It's again going back and switching things off. So we switch the light source off, the atmospheric fog off, the fog off, and just keep the sky dome on. We check if the sun is fine or not in this. That's the light source. How it looks. Is the atmospheric fog interacting with it fine? It's fine. It's not really too harsh. And how the fog looks. So maybe you will think, okay, that the fog is too much. So you can just change the fog again. You can go up. You can tweak it a bit more, and maybe you can also actually bring it a bit towards the yellowish part so that it merges better with the overall setting. Okay, but I'm gonna just keep it the way it is. The other thing is, before we move forward, is that there is a shadow setting here. When you use such a big scale, there is always a problem with the shadows. So to show that, I'm gonna just show you what I'm talking about. Just bring the cube here, right? Just bring the basic cube here and just scale it by 10. So if you use here, okay, my sun, let's just increase the sun a bit so that we know that we can see the shadows a bit more. Let's get it to 4, maybe increase the height a bit. Yeah, let's increase the height there. So now you can see the shadow here, right? But okay, let's duplicate this volume again. So to duplicate it, you just need to do Control W, right? And you duplicate it. So here you see that you have a shadow, but as you go back, you lose that sense of shadow, which is not really what we want in such a big landscape, right? Because when you look ahead through a vista or something and you create a really nice big vista towards the sun, you would have a lot of trees, maybe there are a lot of mountains, and you really don't want to lose that shadow element. So what you need to go to do this is you need to go to a light source. So let's just make this the sun because that's the sun. So you go to your light source and you go all the way down and you find cascading shadow maps. So this is the thing that's actually affecting your shadows. And you just increase it by add just 2 zeros, and you see now that the shadow is back there. So see, there is no shadow. And if you just add 2 zeros, you have the shadow on. But the problem is you're also losing the shadow density here. So the detailing over here you are losing. So if we go back, you see here you have sharp shadows, while on the back you have no shadows, but you add this, you lose the here. That's because if you do this, yeah, the number of dynamic shadow cascades is really low right now. So you just need to increase it to 10 and you will get that detailing back here. So yeah, that was the end of part 1, where you just deal with shadows, lighting, and basically set up a screen scene, right? So next, what we are going to do is we are just going to create some kind of mountains. If you have seen the pictures that were shared by Futurely, right? We're just going to see make a scene where we have mountains, and in between the meadows we have some kind of a pavilion with a road which is leading up to it. To make the patterns, the mountains, what we are going to use is we are going to use alpha brushes. So again, you can go to Brushify, you go to alpha brushes. So here you will find the alpha brushes, and to use an alpha brushes, right, to sculpt it across the landscape, you can go to modes, select landscape. You have here the sculpt. You have again 3 things: manage, sculpt, and paint. You just go to sculpt button. You will find here there is a circle. Just go to circle and select alpha. For me, I have already selected it because I was using this file before, but if you don't have anything here, just select this model here and select this arrow and it will be loaded again. So now what you need to do is just bring this down and let's see what's happening here. Can you see something? No, you can't. That's probably because my brush size is really small. So you need to just increase the brush size really big, like something around 30,000 maybe, because it's like a mountain, right? So it's going to be really big. So also in your case, it might be that this is on auto rotate. If you're using a new file, you see this, it's like a fish going around my landscape, and really don't want that because I want the control over my rotation. So just unhide the auto rotate button. Now, if you click something, yeah, nothing really happens because it does happen, but really less. But that's because my tool strength is less. So just increase it to 4 and boom, you will have your landscape here, right? Now, the other part is that, just a second. Yeah. The other thing is that if you go to increase it a bit more, you will have 6. Okay, that's maybe a lot. But also the other thing is that if you use the clay brush here and you don't use it, the clay brush softens the whole landscape a bit more. And if you don't use the clay brush, it will make it a lot more jaggier, right? So it's your idea. I mean, if you want the jaggier version, maybe I want the clay brush because it's more softer and I prefer that. So I think 6 is quite a lot. So let's keep it to 4. The next thing is you can just rotate the landscape. You can put it over here. Again, you can select it like this, rotate the landscape, use it here. You can, there's also different channels have different kind of landscapes, by the way, the mountain alpha material. So red has this kind of an mountain ridge. The green has a different kind of mountain ridge. So if you use green, rotate it, you will find that, okay, you have a different kind of a mountain. So again, you will have a blue one, which will create a different mountain over here. So you can, yeah, you can just have fun with it. You know, I generally use the red one because it's quite realistic. And 4.5, just increase, decrease, and see how it goes. You can also create it again and again on, you know, different kind of on top of another mountain. But what you need to create then is kind of a scene. So either you can create a realistic geolocation and get the height maps, make an alpha map out of it and use it here, or you can just create a new kind of thing here, you know, which has never been built before, and just do your thing. So let's see where we are going to put our model. We can always find for a nice, you know, vista, like a road leading up. Maybe I want to make more mountains over here, something like this. Okay, yeah, I think I got where I want to put my pavilion. Let's put another mountain over here. Yeah, okay. So this is how you create mountains. The next thing what I want to do is I want to put my model inside this place, right? So how do you import a model? So let's just go out of this mode, go to your content browser. I have already a pavilion here, but generally what you need to do is you need to import, and you can basically select from wherever you have an FBX file or an OBJ file and anything, and you can just drag and drop your pavilion here. And my pavilion is really huge, so I need to just deal with the scale of it. So I think it was 0.09, 0.09. Yeah, so just whatever you bring, you can just bring it here like this, you know. And while exporting, actually, you need to make sure that wherever you are exporting from, you know, Maya or Rhino, just make sure that your pavilion is at 000 so that it's easier to control this axis. Otherwise, your axis will be somewhere really far off, and then you have to manually bring your axis here, snap, and it's a lot of operation. So good practice is to bring your axis, your model to 000 and then export. Let's rotate it by 90, right? By the way, when you rotate it, you can also have steps here. So you can also put, okay, I need 90. So every time you rotate it will only be rotated by 90 or 5 degrees or 10 degrees. So let's bring it down. Let's see where we want to put it. Maybe I want to put it somewhere over here because it already has a slope, somewhere near a slope. So somewhere, let's see here, here. Let's rotate this. Let's see what we want to do. Okay. Yeah, let's bring it here because what I'm going to do is I'm just going to go to quickly to landscape again. With my alpha brush on, I'm going to do it really less, and I'm just going to hit 1 now. I think 0.5 should be, 0.2 should be good, somewhere here. Or maybe rotate it. Yeah, you actually have to do a lot of tweaking, play around and see how it goes. Yeah, I think I like this. Okay, and now you need to go out of the mode again, select your pavilion, see where it is, bring it up, and try to position it somewhere here, maybe, because what I'm gonna create is trying to create between these valleys some roads, right? And which will be leading up to my pavilion. And I'm just gonna put my pavilion over here, a bit submerged in the landscape. So this point, like you see this one. So let's bring my this here. This point will be somewhere here. Let's bring it a bit out. Yeah. Okay. So next thing is let's make the roads. Let's save this file. Let's make the roads. So how you make the roads is, again, you have to always go to landscape for all of these things. You will go to manage instead of sculpt, go to splines. And when you go to splines, you just have to select your control button and hit, you will find this icon, right? So this icon is like your spline control points. Just hit another button here and you will be connected. You will have a connected road. And if you select this, you will have an automatic generation of this kind of a Bezier spline kind of a thing, which goes maybe all the way here. You can also select these buttons, right? And put it up and down if it's going down or something. Let's just make it quickly something like, which seems as if it's going inside this element. Something like this. And let's now make the road, right? Because this is not really a road. This is just a spline. So how you do that is you just select one of the points, and here you have the option in details, select all connected segments. So you go into select, so it's selected all the segments. Let's bring this up a bit. And what you want to do is somewhere here you have wait, yeah. So where you see landscape spline meshes, you have spline meshes. So just select this plus arrow, open up this 0 button, and you will have an option to put your mesh in. Now, where you will find the mesh, this time you have to go to somewhere else. You can go to the meadow environment set, because I found a really amazing road here. And you can go to roads, environment, roads, meshes, and here you have two kinds of roads, right? So you can select one of the roads and again, select it and hit, and that's it. Your roads is set. It has an automatic mapping on it, so you don't have to do anything. So you have two kinds of roads, and you can then modulate your button up and down to see how you want it. But the thing is now that it's not really aligning with your landscape, right? So how to deal with that? So what you need to do is again, select all your segments. So here you have your deformation landscape tool, and you just go there and say only selected, that's it. Your model is now deformed landscape according to your road. And if you think that it's too harsh somewhere, that's where your sculpt tool actually comes to work, right? So now what we can do is we can actually do this. We can again go to splines. We have your control button on, and we can do another road here. We can make this up just to show as if it's going somewhere else from the horizon. And we can again say all connected segments, and boom, there it is. You have your road here. But sometimes it can be look a bit harsh over the edges, right? What you need to do for that is you need to go to your modes, sculpt tool. No, so here you have all the sculpting thing. You can just use it to smoothen it out and flatten it out. But what you need to first do is, because we have still the alpha chosen, just go to circle. Our circle is pretty huge, so let's get this down to a reasonable amount. Something like this is fine. Let's go to the smooth. So what it will do is it will just create a natural gradation between this line and this part. So there you are. You just need a natural gradation between the two. Okay, this looks fine. Okay, so next thing. Okay, so the next thing is that there is the lighting that we need to check, but I think the first thing that we should do is, since we are already here, is to show that how to create all this sculpting around this area, right? Because this is the area that we now need to detail. But before that, it's always a good thing that you basically save your level every time as a save as. So let's just level this as 0, 2, right? So again, let's go to mode, landscape, and let's sculpt around the landscape, around this pavilion. Let's go to sculpt. So what sculpt does is that if you just put this a bit lower, it will go up, right? If you do sculpt, it will just go up, but we don't want it here. What we can do is, if you want to go back, you can just flatten it. You have flatten target. So basically we can select any place where there is a flat tool and it just flattens it out. That's it. It's flattened. So the sculpt tool again, and we will this time select shift, and what it will do is it will now go down. So now it's going down. So if you see this, it's basically went down because we want to create some kind of like a river bed or a lake bed or something. So we can just quickly do a very rough we are just doing something rough right now because I don't really have that much time to create a nice looking landscape, because that takes quite a bit of time. Also, we need to make sure that there is nothing here because the water needs to go down all the way here. So we're going to make sure that this is like this. Let's get this a bit back up. So we can also, you should always modulate with the brushes to make sure that it's going smoothly, right? Again, a bit of sculpting. Then if you use smooth, so that there is a smooth transition between everything. Also the lake bed, there needs to be a smooth transition. Just make sure that there is a smooth transition. Let's go down and see how it looks. Yeah, we need to sculpt here a bit more. So go again to the sculpt tool, shift, and here it is. You have the bed again. Yeah. So that's what you need to do over here. Okay, and let's do save current. Okay, so let's bring in the water element now. So for that, what you need to do is just go to your place action actors. Over here, you will have a lot of things, right? Like the cube, sphere, cylinder, cone. But what we need is a plane. So just put a plane here, drag and drop. Go to your normal selection. In the details, just put this up, your detail with the plane selected. What you can do is you can just make this maybe 10 by 10 by 10. No, 100 by 100, I think, or maybe even bigger. What's happening? Let's get it again. Okay, it went away, so we need to get our viewport again. Sorry guys, I seem to have lost one of my viewports. Place actors. Okay, so here you go. You have your plane. You get this. Boom. Scale it up to 100. Yeah. Okay. So this works. I don't know what I was doing before. So 20, 20, right? So maybe get it somewhere here, somewhere over here. 50, 50. Let's see how this looks. Bring it a bit up because it needs to be a bit submerged in your lake. So now we see that again there is a bit more that the lake can go. So let's get this to 100. Yeah, 100. Okay, so that's the basic shape of your lake that you're getting. Now again you have to put in your material for it. So just go to content folder. Again we will be going to the brushify. Let's go to water, and you already have your materials here that have been set up. So right now you just have to select and that's it, boom, put it over here. And you have a very natural looking water. And if you go inside the material itself, you can actually create different kind of variation. If you want a lot of foam, you can create a lot of foam, for example, but we don't really want that because a lake won't have that much water. You can, change your foam amount again, but again, keep it as natural as possible. Very less and subtle and stuff like that. But you can also play around with the waves and everything. But that's for you guys to see. And so the basic concept is that the pavilion is a bit half in the water and half on ground. So that's what it's done. Okay. So again, let's revisit the lighting a bit, because if you see this part, right? So we are gonna maybe create some kind of, you want to create some kind of views from here, but this kind of a line, it's really not natural. So somehow we want a bit more shadow over here. So what we're gonna do is we're gonna go back to our shadows. So again, what you can do is, just a second, let's put your post-processing thing in the lighting. You have your landscape. Let's put it that there. Plane goes to landscape. Okay, let's put off our fog, exponential fog, and sun. Also, skylight can be on. Maybe put off the sky dome. Okay. So again, when you test the lighting, just put everything one after the other, right? So your sky dome is on, boom, fog, and your exponential height fog. But you see that the fog is not really doing anything now. So what you can do is you can increase your height fall off, right? You can try to increase it a bit, the density, play with the height fall offs a bit with the density, so that something in the background is a bit more foggy. Something like this maybe. Also try, you can change this thing to a bit more whitish color or yellowish color to match the sun, something, whatever you like, but I think I'm just going to keep it for now here. You can also try to tweak the fog. So everything, basically it's a lot of process tweaking again and again and again, and trying to, a good idea is to trying to create mood boards, maybe try to get some reference pictures, and from there you can really get an idea as to what you want to achieve. But let's switch this a bit less, maybe. Yeah, let's go to sun, and you can also, increase it and see what it does. Again, go to skylight, recapture it, because that's a good idea always to do. So let's save it here because we have our sculpting done. So the next part is the detailing, which I'm going to quickly do because I think it will take about 15-20 minutes. Probably I have that much time left. So what you need to do is, what you see here is that you just have your green layer, right? That's your base layer that we had put. But generally, this is not how a landscape actually acts, right? So for example, if you want something here which is more transitioning towards maybe a mud texture or a soil texture or anything, and we already have that in our paint layers, the material which we were working for before, and we saw it, right? That we have the material, landscape, and over here we have all the materials, you have pebbles, ground cover, mud, snow, and everything. So we can just put that on. But first, let me tweak the sun a bit because I really don't like how it is right now. Also the dome. Let's do this. Let's put the sun a bit. That's fine. The sun is not on. Sorry, guys. Let's try to put again, align the sun along the bridge up. Okay. Also, a good idea is to just link the sun with the sky. Sun with your sky dome. So whenever you move your sky dome, you basically will move your sun along with it, right? So that it's right there. And now we can see, okay, my fog is a bit high. So let's just bring it down a notch. And even this thing, you can bring it down a notch. So there it is. Yeah. Okay, so now on to the paint layers. So let's quickly get to the paint layers. So what you need to do is go to modes, select landscape, and here you will find again sculpt. Let's go to paint, bring it down. So what we can do is, okay, that we probably made a decision that we want to make a mud here, right? A bit muddy. So we can go here. Right now there is none here, but you can select here and say create weight blended layers. And you need to say where you want to select it. So let's share it in our where we are doing the modeling right now. Okay. So that's done. So we just select the mud layer, and you go over here and you do just go over it. So now it will take some time to compile because it's working on a new segment of the landscape. So just wait for it to compile. It takes a bit of time. Meanwhile, I'll save it. Let's wait for it to compile, and you will be able to see what's really happening over here. Yeah, so here you see that it's now a mud, right? It's basically this thing has a bit muddy kind of a landscape over here. And what you can do is you can also smoothen it out so that you make sure that there is a nice transition between the green and the mud, right? So similarly, we again use mud, and we probably say, okay, we want to have some kind of mud all over here. And we just, sorry, it's in smooth, so that's why it's not happening. Yeah, so something like this, you just want mud over here. So again, smoothen it out so that you have a nice transition around. So the next thing what we can do is we can take a forest element. So if you don't have forest, just take the forest layer, again, paint over it, and again, it will take some time to compile. Every time you make a new element and put it in your landscape, it will take some time to shade it. It wasn't taking this much time when I was modeling it, but perhaps with the zoom and everything on, it's taking a bit of time to process it. But yeah, just wait for it and it will be done. So probably I'll show you only in this section and not go anywhere else, just quickly how to do these kind of processes. Otherwise it will take a long time. Yeah. So here you see that it's changing the color and it's actually putting in the forest layer in now. So here is the forest layer. So again, you can do the smooth thing so that there is a fine transition between everything. It's a very good idea. Another idea, I will show you a quick way to actually go through it. If you go to lit, you have your visualizers. No, yeah, you go to buffer visualization and you go to base color. So here you will find all your base colors. So even if you do something, right, like you create your mud texture, then you create your forest texture and your grass texture. So you can actually have a better precise control over what you're doing there because you are not affected by the light maps or anything. So again, you can go to your lit layer. So let's see what happened when you did the forest layer, right? So it created all these rocks. So the forest layer had these rocks and kind of flowers and everything over here so that it has a more realistic effect. And it's not just grass, right? Similarly, you can just create different layers, right? You can have the dry grass, and the more you go up, you just create the dry grass over here. And again, it's compiling the shaders. So let's wait for the shaders. Okay. Yeah, we will wait for that. In the meanwhile, I want to show you the Fadous because it's quite a nice layer. Just make it a bit small, the brush size, the tool strength. And over here, for example, if you have a muddy texture like this, you will see that it's a bit, you can see that it has a reflective quality, but sometimes you also want some kind of mud over here. So I'll quickly put some mud over here while you see there what happened. Yeah. So here you have that dry landscape that I was talking about in between that, okay, the more you go towards the mountains, you have a dry landscape. So you have all these shaders you can work with and you can put snow on top or you can have a desert and everything. So it's really easy. But that's because then you have to find assets like this. And that's why I'm telling you that just go every month and find for assets. There are a lot of free textures out there. It's really nice. Let's see if the mud is, yeah. So here you see that these are the puddles and it's actually reflecting real time. So if you put any object over here, it will actually reflect that. So that's also pretty nice and handy. So once you have this, what we're going to do is we're going to again save, and we're going to save this file again as CO3. Okay. And now what we want is foliage, right? What if, because these are things that are nice, but what if we want actually plants and everything? So generally, again, you can go to Brushify and go to meshes and you have foliage, right? You have a lot of bushes over here and here you will find, but generally, like this is, for example, how you generally bring foliage in, but that's a bit weird. You don't really want to do this everywhere. right? So for this, what you can do is you can again go to landscape, sorry, foliage. When you get to foliage, you will find here that there is a drop foliage item here. So you can either take these static meshes, but generally in Brushify, what they have done is, just a second. Yeah, they have these foliage types. It's just a doc file which has all the information that you need, and you just put it here, right? And you can basically check or uncheck these items, and let's see what it does. So just select one item, and you have these kind of things, and you can change here all the parameters. You can change the density, you can change the size if you want a bigger size, and we don't want that bigger size, and you can just start painting it over here, and that's it. What you have is a really nice amount of, you know, plants and everything, and over, like, you can have this all over the landscape, and you can have different kind of things. You can add the material to it, you can uncheck that, and maybe have different materials going towards the mud, so something like this. And you can also make it somewhere here if you want to make some kind of, you know, something like this. You can create a lot of materials over here, and uncheck that. Maybe we want something else going towards here. That's also nice. So that's how you actually do this. And what I did in the picture that we saw in Futurely was that I created some rocks and put it over here, right? So we again go to content, you go to Brushify, you have the meshes, you have the foliage, you have the trees. You can just go and select and bring it here. It's just a drop and drop, just like Twinmotion if you guys have used it. And let's go out of this mode again. So select. So that's how you actually make the roads, the foliage, paint over the landscape, make this over the building and sculpt around the building, right? Put in your trees and everything. Because the time is running out, what I want to show you in the end is how to take out your screenshots, right? So once you have your screenshots in, how to actually do that. So generally, if you just want a screenshot, you can do F9, and that's a screenshot. The next thing is that you want to, you can also go here, right? And you can create a high resolution screenshot. And what it does is that with one, it will just create your panel. That's it. And if you do it 3 times, it will multiply your panel by 3 times. So that's quite a lot. And if you include your buffer visualization targets and rendering pipeline, it will create all the different maps, you know, like a roughness map and a different kind of maps. But there's also sometimes that you want that, okay, you want a specific kind of a screenshot, right? Like if you want like 2K maps or 3K maps. So how do you do that is generally you have a log here, and yeah, in my case, it's not working. Message log. No, let's go to, yeah, I generally don't use this, but I thought I would. Output log. Yeah. Okay. So if you go to output log, and here you have the command line, right? So in the command line, you can just write high res shot. So here you get high res shot. And after the high res shot, you can just specify you want 1920 by, you know, 1080, or you want a 2K, or you want a 7K or 8K, and it will basically select it, and it will go to your the place where you have saved the file. So that's pretty easy. So let's, what's happening? Yeah. Just a second. I think it's something has stopped working here. Escape. Yeah, okay. It was stuck in the command line. And in the end, basically what you can do is, I think in my case, this is all the things I did, but much more nicely because I had more time. And over here in 40 minutes, it's pretty difficult to make your landscape pretty nicely and detail everything. But generally in the sun, what I did was I did one change. In the sun, if you go, you have these kind of light shafts. Just go to light shaft plume, and what you have is these kind of god rays that we say in the game engine. But what you want to do is you want to really scale it down a bit, and you really want to play with it and see what you can get out of it. So this is the setting where we actually got those kind of lights coming in through this kind of a model, right? And you want to have nice kind of lights going through it, but you have to actually play a lot with it and see what's gonna work and what's not gonna work. I unfortunately I didn't do the settings for this. So yeah, you have, maybe you can just go back to my model and you can see there is the setting here and you can see what's right or not. So yeah, I guess that's it, guys. And I think with this, I have told you what and how to place all the materials in and how to create a basic world around.
That's awesome, Arav.
Wow.
Yeah.
Wow, Arav. And
Arav, there's one question that we can just show. There was a
Yeah.
question in chat asking how can we import an FBX file into Unreal? Maybe you can show how to quickly get it.
Yeah, I actually showed you. Yeah, but I will show it again.
Oh, you showed it? Okay, then maybe people can access it from the recording.
Yeah, because in the import, right? I showed it
Yes,
when I was
yes.
importing the pavilion.
Perfect. Yeah.
Yeah. Yeah, but there's so much to it. I mean, 40 minutes is so less to actually make the landscape again because you need to really control and
well,
everything.
this is kind of like a Pecha Kucha kind of a format where you have 40 minutes to show something, and it's kind of a challenge for the instructors as well.
Yeah.
Actually, we should call it a Pecha Kucha, Eric.
Could be cool. Yeah. I guess, I mean, this is it, right? We made it.
Yeah.
We made it. Yes. And there's 200 people with us.
Yeah.
Who made it with us. This is amazing. Guys, thank you so much. Thank you, especially for the instructors, for agreeing to stop by and share their knowledge. And thanks for all the awesome people who are learning all day. This has been truly a celebration because 2020 was if it was a good year, it was a good year because we learned so much from one another. And I guess it's a niche of a profession, but it has boundless possibilities where no matter how good you are, you can still learn from a beginner as well, let alone an expert, or so many talented wizards like the people who taught us their knowledge today. So thanks for everyone for stopping by, for being a part of the community and learning and improving all day. And of course, happy 2021 as well, because we're not going to see each other probably. So happy early Merry Christmas to everybody. And if you're going to join the Sanzar world, I just want to show you some tips and tricks for stuff that you can do there. Let me share my screen. So basically, when you're in Sanzar and you go to the link that we shared with you, it's, but you can also look for it anyways. Forgotten Cave. Just a second. Explore.
Guys, before anything happens, please stay back for a couple more minutes. We're going to have the selfie.
Yeah. Exactly. And then there's the Forgotten Cave Future Xmas, right?
Yeah.
Not the Christmas, but the Xmas one. And then once you visit, actually, there's already 7 people in there. You guys missed the tutorial and went to party. I saw you guys partying hard. All right. So as soon as you're in here, let me do a share screen with the computer sound. You basically there's, oh my God, there's so many people already. Okay. So once you're in here, you can see the lights and everything. And this is a world that was built by our participants of Virtual Entities workshop series that was mainly about this kind of gamified architecture environments. Namely, they are Christophe Gallant, Arthur Azoulai, who was with us also today. So a big shout out to them. And there's also Jay Daga, Shan Dowsey, and Sanya Halim with them. So big shout out to 5 of these guys who made this world. And we remixed it for this special event and made it into a party space. So very sorry about that because it was a very calm place before we touched it. And basically there's this computer here where it's democratized. This is a democratic party where you can control the lights yourself. You can just come in here and click on things that you want to turn on and off, basically. So for example, right now, almost everything is off. But if I come here and I turn on the star lights, for example, I'm just going to get these lights, for example, right? So feel free to experiment with that and see what's up. And you can also come in here and move, click on this. And so it moves up and you can see this opening and everything. So you can experience this space and just move around and feel free to see the Easter eggs in this place and everything. And just have good fun. Enjoy. So there's crazy music going on. So see you there.
And
I guess
guys,
this is the way we party, right? In 2020, yes. It's very fitting to have a virtual after party with everyone. All right, I'm gonna stop sharing and I'll see you there.
So yeah, before we leave, guys, let's have the selfie. And another additional detail to this, whatever Eric showed just now. So when we have Sansa, right? Now that so many of us are going to start to enter, it's going to create instances. It's almost like a multiverse. There will be parallel universes and the party keeps running. So you need to go to the world and you need to choose view instances. And from there, you can pick the world. And if you guys want to go to a specific world, just share the instance URL with each other and you can meet each other in the specific world.
Right.
Yeah.
Basically, there's usually from 35 to 50 people in each world, just for performance issues. So yeah, you guys can visit each other like that.
Absolutely. And
yeah, actually, about low, there's a question about if we kept the low gravity. Yes, we did keep the low gravity, but also in the computer, there's a button called 0 gravity. You can click on that and there's no gravity after that anymore.
And if you guys have VR headsets like the desktop VR headsets, Vive or Oculus Quest or Rift, you can plug it in and come from there instead of using it just on the keyboard. It's much more immersive that way.
Yeah.
Yeah.
There's a question about the link. We did share the link with you, but we'll share it again in the chat and we'll share it also in Discord so that you guys can join. And yeah, let's see. We'll just share it again in the chat.
Yeah.
All right. Loki, are you doing the selfie? Actually, this is also being recorded. So we're going to have a big selfie together.
Guys, you can unmute yourself, by the way.
Yeah, absolutely. Actually, yeah. You're allowed to unmute yourself now.
Yeah.
Awesome.
All right. So many familiar faces.
Yes.
Busy workshop, guys. Really, really helpful.
Hey, Ramzi. Thank you. Hey, Siddharth.
Thanks, everyone, guys.
Right.
It was a great opportunity.
Yeah, Vansi, Eric, thank you guys for the opportunity.
And thank you guys for stopping by. It's been, I mean, we didn't know if it was going to work. We were 90% sure.
Yeah.
We've never done such a thing. So we were like, let's do this and see what happens, right?
Yep.
And
awesome.
it's such a great thing to do, right? Like to take the back seat to you guys so you guys can do the sharing. It's really awesome. Okay, let's do it.
Yes.
Loki, are you ready?
Everyone turn on their cams.
All right.
Let me see.
The reason Loki does our selfies
There's
is
a
because
pin.
he has the largest screen.
He's the limousine Loki. He's got the...
Yes, we do a selfie.
I was going to ask you about your screen, Loki.
Every time we share a story from Loki.
Look at Arthur's screen. We have someone.
We have a new futurely.
Actually, every time we share a story from Loki, there's at least 5 people on Instagram asking us, what kind of a screen is that? Where can I buy it?
Even the workshop doesn't get as much traction.
Exactly. All right. So the recording, about the recording, guys, we have this announcement to make. So we decided to make the recording available for everybody for a week, starting now. So most people were asking for a day or two. We're basically gonna make it available for a week so that you guys can review your work. And once you do, just practice and produce some results, and we would love to see them. So if you produce stuff that you produced with what we showed you today, definitely please tag us and tag the instructor you learned from, and let us know, basically, right? So we can see your work, and we're gonna definitely repost them and republish them. So would be really, really awesome to see. That's why we're sharing it for a week, so that you guys can have some time to pull off some kick-ass results. Right.
Absolutely. And also you can feel free to drop it on the Discord channel, the show off channel specifically.
Right. And definitely use the Discord channel for any questions you guys might have. And definitely let us know how this format worked for you. It's the first time we're doing it. So if you guys have some ideas about how we can improve it or how we can make things better, what you liked, what you didn't like, you can definitely let us know about that. Which topic you like the most or would like more in-depth workshops about that and everything. So just keep communicating with us. We're here for you. And we would love to hear from you again.
Yeah. We will send out a feedback form on that regard, whatever Eric said just now. So guys, please take 3 to 5 minutes and fill it out for us, because that's going to be super valuable in organizing the future events for us. It's really, really important for us. Yeah.
All right. So there's a question about where the recording is going to be shared. It's going to be shared on Discord. So you need to be a part of our Discord server for you to view the recording. There's a lot of thanks. Thank you guys for dropping by. It's been
Arik, I had a question.
Yeah.
There's a lot of questions that were being asked during my presentation, right? During the webinar, and I just steamrolled through them. I think I just went through the modeling process and I didn't really look into them. How do I respond back to them? Will there be a question list?
The chat, the transcription is there. We have the chat. We can collect the questions and drop them. But would be nice if you guys, if you still have any questions that was not answered, maybe the best way is to go on Discord and drop it there in the Christmas special channel and tag the instructor who you think will answer you. And basically like that, that would be the best way, I guess.
Yeah.
Yeah.
Or just follow Neverlab. Yeah, it's the same.
Yeah, exactly. You can also just message people directly, right, on Instagram.
Yeah.
But the best thing about Discord is that once you ask a question, others see the answer as well. So it's a good way to have it answered for everyone instead of answering different people separately. Okay, I guess this is it.
Yeah.
Thank you guys again for dropping by. It's been great, and let's go party. There's at least 20 people already in there.
Do we have the selfie yet, Loki?
Yeah, bro. I've taken all of them.
Okay.
Awesome.
This
Guys,
was the biggest Zoom.
also a special shout out to Loki and Vanni. They are our moderators, and they always constantly operate on the background, and you must have bumped into them on the Discord channel. They've been phenomenal with their work as well. And today we hit 5K followers on Instagram, thanks to the amazing event and the amazing people, all of you that joined us. And we also crossed 1,000+ registrations for this workshop today. Yeah.
Crazy, guys. I mean,
yes.
When me and Mamsi were organizing this, we were like, if we get 100, 200 people, we'll be happy. But now,
yeah, that's it.
All right, awesome, guys. All right, see you soon. Yeah.
See you.
Yeah.
See you.
Thanks, guys.
See you guys.
Thank you, everyone.
Goodbye.
Good luck to everyone.
Good luck, guys. Bye bye.
Merry Christmas.
Merry
All right.
Christmas.
Merry Christmas.
Merry Christmas, everyone. Ciao.
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 Ciao, ciao.
I'll stay.